Hello, everyone, and welcome to day 2 of Amplify Days. I'm super stoked to be here again, kicking off the day. So hopefully you're as excited as me. I put this GIF here. I'm going to go into a little bit of the same intro as I did yesterday because I do see some new people here that were not here yesterday. And then I'll get to some housekeeping items, and then I will kick it off with our first speakers who I'm super excited to present. Okay, so what the heck's Amplify? If you didn't come yesterday and you've never heard about Amplify, I know there's definitely a few of you in that category. I'm going to just briefly break down what Amplify is. So Amplify is actually 4 things. It's the CLI, some libraries in the different frameworks that we all use in the front end, some UI components, and then the console piece. And so the CLI will help you create and provision backend resources in the cloud in a very easy, user-friendly way to do so. Because if you ever tried to create a resource in AWS, sometimes it can be a nightmare. The libraries will help you take advantage of those resources in code. The console will help you do things like CI/CD for your code base, and as well as just manage all the resources that you've created using the CLI. And then UI components are just there because they're just nice. Who wants to build a sign-in screen 50 million times? I don't. I just want to pop in one line of code. And we are use case based, not service based. So AWS is a very, very large place. As we all know, we have over 100, I think, and 75 services now. It's very hard to tell which service to use and when. And so Amplify decided to build things in a use case based way. So that's some historical context for you, right? We thought jumping into AWS was really hard, especially for front-end developers. Where do I start? What is this service? How do I use this one? Should I use this other service? There's too many options. And so we built things in a use case way. What that means is you just simply say, I need storage, right? And we will tell you which service to use. We basically will set up the service to use in the backend for you using AWS security and best practices. So, I need storage. Well, what kind of storage do you need? Do you need to store images? What are you storing? You tell us, and then we basically make the right decisions for you and provision the backend resources. And so we have all these categories listed here on the bottom, right? We have analytics and auth and storage and data store and all these amazing categories. So everything in Amplify is definitely use case based. And all you have to know is that I need this thing and this generic term, insert here, and then you're able to easily, quickly get started on the cloud. So that is our hope for Amplify. So we hope that by the end of this conference, or by the end of your first time using Amplify, you are, writing only a couple lines of code. Maybe you're even writing it with your feet, like this lovely gentleman here. It's that easy to get started. So I just want to say thank you to yesterday's amazing community speakers. We had a fantastic day 1. If you missed any of their talks, they will be available very shortly for you here. So this is our day 2 agenda. So we're going to first talk about what Orangetheory built with Amplify during the coronavirus pandemic. And then we'll have a bunch of talks today. You don't want to miss my talk at 11:10. It's going to be awesome. Sorry, that was a little self bump. Okay, so housekeeping items. I got these questions a lot yesterday. So all the talks will be posted to YouTube. I know yesterday I said 7 to 10 days, but it seems that we were actually able to do it sooner. So yay to those of you looking for the videos. We're able to do it in 1 to 2 days. So if hopefully you guys all understand that they will be posted to YouTube. And then questions. If you have questions for the presenter about their actual content, please make sure you ask them inside GoToWebinar, because the moderators for the presenters are not necessarily looking at Discord for those questions. If you have general questions about Amplify or technical questions, please use our Discord chat rooms for those. So, if you're going to ask something like, when should I use Amplify Data Store? That is a general question, right? Please make sure you're using the Discord for those. If you have a specific targeted question to the presenter about their talk or the content they presented, the moderator is happy to ask them live for you. And then some of you mentioned that you had trouble joining the Discord yesterday. So this is the new link. It should be really easy. I will post it in the chat, discord.gg/amplify. I think you mentioned that it might be expired. So if a bunch of you are hitting it at once, it might be that it's saying that it's expired because too many people are hitting it. So just keep refreshing until you see it if you're still unable to join. And then here are some extra links. So there's the Discord one again. This is our GitHub. All of our code is open source. Amplify builds everything out in the open. So that means if you have feature requests, if you have issues, we will directly refer to our GitHub probably a million times today. So please make sure you check it out. And if you have questions or specific issues that you're finding, that is the place to post them. Okay, so without further ado, I would like to introduce our speakers, our first speakers today. They are from Orangetheory, and they were able to get an app called Orangetheory at Home up and running with Amplify when all of their business was taken suddenly online at the beginning of this coronavirus pandemic. They were able to do it super quickly, amazing fast turnaround time. I'm really excited to introduce them. So we have, let's see, we have Nicole here, and William and Pedro. And then I'm going to make, I think, Nicole the presenter. And take it away.
Thank you so
Nicole,
much.
I think
Nikki.
you're on mute also.
Can you hear me now?
I can hear you, Nicole.
Great, thanks, William. Hopefully everybody out there can see my screen. So we're really
so we
excited
can't
to
hear
be
you.
here.
Okay.
So I can hear. I'm not sure if everyone else can.
Yeah, I can hear her.
Never mind, mine was.
Okay. All right. Well, we are really excited to be here today from Orangetheory. For those of you who don't know who Orangetheory is, just a couple quick things. Orangetheory is a fitness boutique company. We are worldwide. We have over 1,400 locations across the globe. We like to refer to ourselves as a science-backed, technology-tracked, coach-inspired workout. It is a really big part of what makes members so fanatical and passionate about Orangetheory. We are really a very small company, though. We have about 150 people, over half of which are technology employees. So it is a fitness company, but really in our heart, we're a technology company. So you're going to hear from a couple of us today, myself, Pedro, and William. And Pedro is our enterprise solutions architect. He's been with us for a number of years and it really gets to oversee a lot of everything that happens across our platforms. And William is one of our senior Android engineers and has been instrumental on our mobile app over the past year or so. So Orangetheory wasn't always a technology company. I joined Orangetheory in early 2019. But long before I joined Orangetheory as an employee, I was an Orangetheory member. I joined myself back in 2014 because I wanted to work out, I wanted to be fit. And I really, really liked the technology aspect of the workout. It really spoke to me and it really appealed to me to tracking my personal fitness. But what I didn't know then was none of the technology that I was using on a daily basis was owned or operated by Orangetheory. It was all third party. And it was kind of cobbled together in the background. And in 2017, that changed for Orangetheory. They created a technology strategy. We stood up our first AWS server in November of that year. At that time, Pedro, William, and I, we were not at Orangetheory, and the tech staff was just a couple people. In 2018, that commitment to technology moved even further. They started mobile app development. We launched our own version of, yes?
Your slides are not in presenter mode. I don't know if you wanted to start the slideshow.
They are to me.
Sorry to interrupt you.
Do you not see them in presenter mode?
So we can only see the, yeah, so if you're only sharing PowerPoint and not your whole screen, when you take your slides into presenter mode, we can only still see PowerPoint with like the overview of the slide. Like we still see what you see when you look at, there you go.
Does that help?
Looks good.
I see a white
Yeah,
screen. Okay, yes.
So in 2018, we launched our first heart rate monitor that was created and worked on by the technology team at Orangetheory Fitness, and the tech staff grew to about 25. In 2019, we launched our mobile app in February. We also announced that we were working with Apple and created the OT link that pairs with Apple Watch, and the tech staff grew again. And in early 2020, just less than a year after our mobile app had launched, we had over 1 million monthly app users. We also launched OTF at home. And in just, I think it was less than 10 weeks, we had 8 million views of our OTF at home content. But then COVID happened. And I know lots of businesses were impacted by COVID and what happened after, but gyms were particularly impacted. And in a very short period of time, it was a very quick, less than a week, we had to close every studio worldwide. And we really needed a way to inspire our members and get them engaged in fitness outside of the studio. So we had some strategy on efforts in our digital and mobile platform for showing our users content, but we had to act very, very quickly. So using Amplify, in just a couple of weeks for development and QA, we had an integrated app experience with our at-home video workout content. We were able to launch it from the time studios closed to the time it was in app in just 8 or 9 days. And like I said, these stats are from a few weeks ago, but in a 10-week period, we had 8 million views, over a quarter of which were in the app. And it was incredibly easy for us to do, and it's been incredibly meaningful to our members. And so Pedro is going to talk now a little bit about how we did that. So I don't know if we can turn control over to Pedro.
Thank you, Nicole. I will be sharing my screen momentarily. Hi, as Nicole mentioned, my name is Pedro Gonzalez. I'm an enterprise solutions architect with Orangetheory Fitness, responsible for architecture, both infrastructure as well as software. We're a small team. We play lots of hats. We wear lots of hats, and we all contribute to the amazing work that our company tries to put forward. So, speaking about what our architecture looked like prior to COVID and prior to the addition that we had to do to deliver at-home video, we are really mostly serverless and managed services type of infrastructure. As Nicole mentioned, our very first server was stood up in AWS in 2017. I wasn't even part of the team back then. None of this, probably 99% of the infrastructure I'm about to tell you about was not in place. We started working very, very hard at that point to bring up this backend that could support both the in-studio applications that run across the world in over, by now, 1,300 studios, as well as a baby mobile app that was starting to be born at that time, and we knew there was going to be millions of users. So we decided to use serverless as well as managed services from AWS to help us with that. At the bottom of the stack, we can call it the bottom, or the right-hand side of the stack, we have our data store. We mostly use Aurora RDS MySQL for our transactional data. We have some unstructured data that we stored in Dynamo, as well as some business and analytics data that we store in Redshift. We have a very large data lake that we store in S3 because we bring in telemetry from the workouts that happen at the studios. Under normal circumstances, we would have 1,000 studios around the world doing roughly 10 classes every day with an average of 20 some to 30 members. So for each of those members, we collect roughly 50,000 data points per class. So you can imagine that we have a lot of telemetry, both heart rate information as well as fitness equipment information. And that is all driven through AWS Firehose into our S3 data lake. So as part of the access I mentioned, Firehose, our backend also uses ORMs in both the .NET and Node stacks. We have some custom store procedures that we use for accessing data when it's more efficient. And in some cases, we rely on the AWS SDK for things like access to S3 or some of our DevOps operations, etc. Athena is a tool that we use for doing some data analysis against the data that is sitting in S3. And we're currently in the process of deploying Snowflake as our data warehouse strategy. Above that, we have our microservices layer, which consists mostly of serverless code, serverless implementations in Lambda, both .NET as well as Node. We do have, amazingly enough, at this point, we're calling it legacy code, which is roughly about 2 years old. But we do have a little bit of code that's running on some servers, some EC2 instances running full .NET framework, as well as a few containers that are running some Node code for a very specific set of applications. We also have some batch processing that needs to happen as part of us moving our data around or communicating with our members. And so we have a set of Lambdas that do some of that batch processing to interact with SQS, SNS, and even sending emails out through SES. All of our APIs sit behind API Gateway and are also sitting behind CloudFront. So we distribute the load, and we have some security protection by these services. API Gateway also allows for some level of authentication using API tokens and things like that when it comes to system-to-system communications. And we rely heavily on Cognito for our user authentication. Right, so we use Cognito user pools for our members when they log into the mobile app, as well as for some of our corporate or partner or franchise users when it comes to some of our custom in-house applications. And there are several of those. We have a few applications that we developed in-house and are used throughout our studios. We have a custom developed CRM that we've built ourselves. We have a couple of applications that are used in the studio for doing things like fitness challenges. One of the very key points about Orangetheory Fitness is that the same class is being done across the world on any given day. So if you are in a class in Singapore, or you're in a class in, let's say, Australia, or in the Western United States, you're going to be doing the same class. So we're able to do fitness challenges across the world and capture hundreds of thousands of results through a custom-built web interface. We also have a Windows native application that is the one that runs the classes in the studios and interacts with the network, the wireless network in the studio that connects to the heart rate monitors the members wear, as well as our custom-developed tablets. We've built, designed, and built our own custom tablets. And all of this has happened in the last couple of years that are paired with the fitness equipment and allow us to capture telemetry through the classes. We have also developed our own custom native mobile application for both Android and iOS. And Nicole mentioned some of the statistics, but let's just say, we have very, very large user base. And we have developed an application for the Apple Watch together with a piece of hardware that allows our members to use their Apple Watch to interact with our in-studio network, and they are able to use it as their heart rate monitor for our classes. The AWS SDK also plays a part in some of those applications. And we do have some partners that interface with our systems to provide us different types of data that we share, either from marketing companies or other types of partners that bring us data into our system. Our CI/CD environment rely on both Beanstalk for some of the server or container-based deployments, and we also use Azure pipelines for the rest of the CI/CD process. So now let's talk about the Orangetheory at Home project and how AWS Amplify helped us deliver this. As Nicole mentioned, all of our studios were suddenly closed, and we had to continue to deliver a Orangetheory branded Orangetheory experience to our members. And there were several ideas been bounced around in the office using different products, trying to deliver through some traditional CMS systems, and we took a view together with our our partners at AWS at the AWS Amplify, specifically the video plugin, and how it could help us deliver this experience. So very quickly, from my perspective, delivering the backend infrastructure took a matter of maybe an hour to set up the entire infrastructure for a development environment. But it was very easy from there to move it across our environments. So as you can see here, what the video plugin allowed us to do was set up an infrastructure that consisted of an input bucket where our video producers from the marketing team were able to send their videos. So when that video landed on that bucket, a Lambda function would be triggered, which would then trigger a media convert job. And this media convert job would transcode the source video into HLS format, which is a really good format for variable bit rates for different types of devices and network conditions, and it delivers the best experience to the viewers by allowing the client to adjust to the real-time conditions. And of course, we published this video behind CloudFront. So as you can see, that yellow section there, it's what the Amplify video plugin deployed for us. We also added we made a few additions where we created an SNS topic with some subscriptions to notify our marketing team whenever a video was completed, and then they were able to add the metadata into our CMS contentful, which would make it available to our mobile app. Like I said, the infrastructure was very easy to deploy. The majority of the work that was done and some of the really amazing work was done by our mobile team, and William will discuss some of that coming up. So here is a really small example of what it took. This is an actual screenshot from my laptop where I deployed the Amplify video plugin and basically created the environment, and it generates a CloudFormation template behind the scenes that I pushed into the environment, and it was all done. As Nikki mentioned earlier, this is the Amplify framework, and specifically the video plugin, is an open source project, and I work very closely with the team to address several issues that came up during my implementation. None of them major, but I felt the collaboration with the team was second to none. They were very excited to work with us, and they were really thankful for some of the feedback that we provided. Minor issue that we found was that the CloudFront distribution was not really set up with SSL, so we were quickly able to address that by manually adding SSL to the distribution. The video transcoding was by default not using acceleration. In this case, we actually provided a pull request into the open source project. They accepted, and it was fixed as part of one of their releases. We also wanted the ability to group the videos into subfolders. For those of you familiar with HLS, whenever you transcode a video file, a large number of files is actually generated. The video itself, it's split into roughly 3-second chunks for different types of of resolution. So you can imagine there's quite a bit of video, and we actually generate one workout video every single day. So again, we created a pull request into the open source project, and it was accepted, and it was released. We also wanted the ability to receive a notification whenever the transcode job was done, and we did this manually for now, but provided the feedback to the team. We also wanted the ability to transcode different types of videos using the different transcoding queues. So, for example, we wanted any audio formatted video, any audio formatted file to have its own transcoding queue. And again, we were able to submit a pull request for that, and it was fairly quickly added to one of the releases. The team is also working on creating a set of more advanced configuration settings that can address some of the points that we brought up, as well as some ideas that they've had, allowing users that need a little bit more flexibility, or they need a little bit more advanced configuration, to basically have a mechanism for doing so. And I'd like to now give the floor to our teammate William, who will talk about the mobile experience.
Okay. Can someone make me presenter, please? Okay, can you guys see my screen? Oh, never mind.
Not yet.
Okay, yeah, I'm doing it right now. Thank you. Okay, so how are we looking
Yes.
now? Okay, great. So just picking up where Pedro left off, I'm going to be talking about, from a mobile perspective, what we're consuming from the Amplify platform. I won't go over all the architecture, but some of the more important architecture that's generally important to a mobile developer. So I'm going to start off with the HLS file that Pedro mentioned. And first off, HLS stands for HTTP live streaming. And why is HLS a good choice for mobile in general and other platforms as well? Because HLS allows a media player to have multiple choices of video resolutions for different screen sizes and internet connection speeds. So it's not a one-size-fits-all monolithic file format. There's a lot of choices that can be made here by the player, and the player can actually switch midstream to a different chunk that suits a better need dynamically, say, for instance, if bandwidth quality drops. So what does this mean for the main end user? It means that the end user will see the best possible video quality based on their device's specs, like screen resolution and internet connection speeds. For instance, cell versus Wi-Fi connection. From the diagram, HLS is simply not made up of a single monolithic file, but instead a hierarchy of files. There's a master playlist, media playlist, notice the different types, cellular, Wi-Fi, and even Apple TV. And then there's media segments, which are chunks of video content. Pedro referenced the 3-second chunks of video content in his presentation. So a prime example could be why this would really work out well on a mobile platform is, say a member's doing an at-home workout outside and are connected to a cell network. Then they come inside for the cool down part of a workout, one of our at-home workouts, and connect to Wi-Fi. The media player on the device would switch to Wi-Fi higher quality video when the bandwidth was available moving forward, thus giving a better experience under those constraints. Okay. Okay. So one thing that we Amplify, the team did it in general, is they delivered some really good configurations for the elemental media converter. based on tons of research and development. What this did for us on the mobile platform is it was already finely tuned to work across multiple platforms, so that we saved a lot of time doing end-to-end quality testing. For instance, if we would have spun up our own configurations, there would have been a lot of device level testing with different devices, platforms, et cetera, et cetera. So the time to market was short because we were delivered an already rock solid tested configuration to tell Media Converter how to actually encode the files to the optimum different sets of files, so they could be streamed to a multitude of devices. Okay, another thing that HLS is very widely supported. Per Wikipedia, as of 2019, industry surveys show HLS to be the most popular streaming format. And then there's some other things that we want to note here as far as HLS serving from the Amazon background. Again, from a mobile developer perspective, we don't necessarily need to know the fine details about server architecture. However, it is nice to understand some of the basics to know that the data passed down to the mobile app is served from a reliable platform. So the fewer problems we have on the server side, the fewer problems we have on the app side. With the Amplify Video AWS platform, we're assured of maximum uptime, scalability, knowing that the files are served from time-tested S3 storage, and Amazon CloudFront acting as a CDN with geographic distribution as the front end. So as a mobile developer also, we can be limited at times with available choices for view controls. We might be limited view controls such as media players, and we tend to gravitate to the best and most current controls. When we have to work with the newer protocol, we tend to approach it with caution. The good news with HLS is that it works with most current media players. Consuming HLS in our Android and iOS app was very easy. It was as easy as passing the HLS download link to the media players for mobile players like Exoplayer for Android and Apple native AV Player out of the box. So what you see here is this is just a code snippet from our Android project, and we have a data model for our guided workouts, and simply we just passed in the AWS HLS URL directly to the media player and start it like any other media file we would pass in. We've tested this as well with audio served from the same platform and the same players, and it works just as well. So as you can see, we basically it's a drag and drop, plug and play kind of solution for that. So then, what does this all look like to the user? So as you can see, this is our video on demand screen. It delivers highest quality, low latency video integrated with real-time heart rate monitor metrics. So you can see we are able to easily integrate our existing heart rate monitor information, heart rate, beats per minute, calorie calculation, and Orangetheory proprietary splat points, as well as giving a full length of the video being played workout as in addition to lapse time, and we have pause, resume controls as well. So Orangetheory is able to seamlessly integrate this stuff with the help of AWS, and again, the interface part of this application, this is the one main video screen, but the interface took literally about 3 weeks to implement our design. We use another content management system, but once we got the video streaming URL to match with our certain workouts, it was easy as just copying the link into our content management system to serve it to our mobile app. So with that, I'd like to send it back to Pedro so he can discuss some future things with the mobile application that we're going to do with the Amplify framework.
Thank you, William. And so yes, what's next for our platform? Well, at the moment, we continue to deploy the OTF at home workouts experience. We also have a second part of it, which we are calling OTF Run. So these are guided runs where we have, as I mentioned earlier, we do have some audio that gets transcoded, and our coaches have recorded sessions where the members can actually go for a guided run. And for those who are starting to run, or some of the more experienced runners, and these workouts are very helpful. As you can also see on the screen, we have the ability to overlay. This is real time. You can see it. The screenshots that I'm showing on the left is iOS, and on the right is Android. We are able to overlay on the actual running path the heart rate zones. Actually, that works for both runners and cyclists. You can see the actual heart rate zones as well as the rest of our telemetry. OT Run is in beta and is being used by several thousand members. So we're getting lots and lots of feedback before we make it generally available. And then beyond that, the next step in our digital transformation is the inclusion of an interactive workout. So all of these are video on demand deployments. What we'll be doing is more of a real-time interactive workout to get us closer to the experience the members we get in our studios. And for this, we are working very closely with the AWS Chime team to provide an Orangetheory branded experience. We looked at some of the other technologies available in the market, and we didn't feel like we had enough control over what the experience will look like. So we are working very closely with the AWS Chime team to have interactive workouts. As part of that experience, we will be using another member of the Amplify family. We'll be looking to use AppSync for the real-time telemetry that will be part of those classes, feeding from each of the members over to the coach. And with that, from the three of us and our team back in the office, who was integral in delivering all of these experiences, we'd like to thank you for attending our session and for giving us the time to present how we were able to use the AWS Amplify framework to help us very, very quickly deliver this experience to our members. All right, thank you very much.
Okay. Well, thank you so much for the presentations from all of you from Orangetheory. And we do have a couple of questions from the audience. I didn't know if someone wanted to jump on and discuss some of these questions with me, if possible. From the Orangetheory team.
Yeah,
okay,
absolutely.
Cool. Yeah, so the first question is, and I'm not sure if this is something that you would know. If not, we can kind of just skip to the next one. But do you know who created the HLS adaptive bitrate streaming communication protocol?
I think William maybe can give some more details, but off the top of my head, it's an Apple created protocol, and it goes back quite a ways actually. It's probably at least 10 years old by now. But it's been adopted, by the industry, and we feel, at least for us, it's been extremely useful.
Okay, cool. And then the next question is, are there any cost concerns around the infrastructure deployed by the Amplify video plugin?
Yeah, very good question. we have not seen a tremendous amount of increase in our cost. The transcoding time is very short, so the compute that it uses is it's very minimal. So our workouts are, our videos are roughly 45 minutes long, and the transcoding takes only a couple of minutes. And then probably I would say the larger cost is the CloudFront traffic. So this is going to be served behind CloudFront, but again, it has not been anything considerable to us. There's some storage concerns as well. So for us, delivering a workout a day, you can imagine that, and the high quality that we originally generate, probably about just over 1 gigabyte for about 45 minutes worth of video. The S3 storage could be a concern, but that can be addressed using some lifecycle policies in S3.
Okay, awesome. Well, I think that's it. We're going to be hearing a little bit more actually about Amplify Video from the engineer that created the plugin for Amplify next. So that's going to be pretty cool. But Pedro, thank you so much, and everyone else from Orangetheory, we really appreciate you coming and presenting and being part of Amplify Days.
Thank you, guys. Take care.
So next we have Sam Patzer. So I know Sam pretty well. So welcome to Amplify Days, Sam.
Thank you.
Sam is going to be also again presenting on Amplify Video, and I'm not going to steal a bunch of his thunder, but he's been very integral part of that plugin because he created it. So I'm hoping to learn a lot more about that process and how Amplify Video works. So I'll go ahead and switch over and give the stage to Sam Patzer. So let's go ahead and do this.
Thank you. Perfect. Me too. Perfect. You guys should all be able to see my screen now, hopefully. So hello and welcome, everyone. Thank you, Pedro, for talking about how you guys are using Amplify Video today. He talked a lot about our video on demand platform. We're going to be talking about that for a little bit, but we'll also be talking a lot about live streaming. Something that we just released a new product around yesterday. We'll be talking a little bit about that, as well as some other methods as well. So thank you, everyone, for coming and joining today. And let's get started. So one of the big things a lot of people ask us is, why do we choose video? Video is very prevalent in today's society. We're just literally looking at the top 100 app media or apps in the iOS store. About 48% of them has some sort of content that is video in it. Whether it's an actual like entertainment app where you go like Disney or Netflix where you watch your content, or it's more social media focused, like if it's Twitter or if it's like Facebook, where you have more of a social media aspect of you're posting content that may be video or maybe text. So a lot of times, a lot of social media apps have content enabled in them that is video. And then from Social Media Week, 78% of people watch some sort of video at least once a day. It's whether it's once again on Facebook, wherever, it's kind of very prevalent in our today's society. It's very important in today's society as well, because all of us are staying at home, including me, where we have to find ways of connecting with people. And so video is a way to do so. From CIPCO, it's estimated that 82% of the global traffic will come from video in 2022, which is ridiculous. If you think about the amount of traffic that the internet sees, 82% of it is going to be video. And so that is a huge impact on our future. And so making sure that you can add video to your platforms will be very important as you want to be a part of that future. And then finally, we also wanted to show for some people that are curious, 68% of the people prefer to learn via video over other methods. So for those that are like visual learners, they like to watch something and watch people present. So that's why we're doing stuff like this, like Amplify Days. So just some high level overview is, what is a streaming service, or what is a video service in general? So first, you have to create content. That's probably the hardest thing to do, is coming up with original content that people want to watch. For those that are familiar, if you go to YouTube, you can literally go find views that have, or videos that have 1 to 2 views, and you have videos that have millions and billions of views. So you have a bunch of different content that's out there, but it has to be unique. After that content's been created, you have to go through steps to actually deliver that content. If I were to go and give you an MP4, you would have to download that entire MP4, which can be up to like 1 gig or 10 gigs, depending on your internet speeds. That might not be a great thing. So you have to encode it and then host it somewhere. So encoding it means that you transcode the video to HLS or Dash or different formats that allow you to stream the content instead of just download it. After that, you host it somewhere and then you deliver it. You can deliver it straight from an S3 bucket, or you can deliver it straight from your like home media service, which might be great for a low number, but reality is that you probably should be delivering it over something like a content delivery network or CDN. So we have CloudFront to do so for AWS, but there's other CDNs as well that are just for media services as well. And then finally, you need to have something on your device to actually be able to play that video file. So for example, Apple has AV player, and they talked about their Android player on the previous slide, so I won't dive too much into that, but you need some way to play it. So with all these video players, there's something that is very cool about Amplify. Amplify has a plugin structure that is enabling us to be able to plug into their infrastructure. So what that means is that we literally can dive into Amplify, and when I run Amplify add video, it will literally recognize that I have other resources in Amplify or that this is an Amplify project, and I literally can just append my like existing resources with a video object in a sense. So it allows us to be extensible, and it's really great. There's some docs right here. We're working on improving them. I'm working with the Amplify team to improve them, but it's a great starting point. And there's some other Amplify plugins that I'm aware of that are coming soon, and also that are not managed by Amplify. So keep your eyes peeled on it, and it'll be really cool. And then also, if you are looking at building your own Amplify plugin, there's also an Amplify plugin chat in the Discord. So feel free to ping us. We'll work with you and hopefully help you out. So Amplify Video, though. Amplify Video stands up video on demand and or live streaming and start sharing in minutes. What that means is when I run Amplify Video, and I'll show you in a demo in a few minutes, literally you just run Amplify add video, and you are pretty much able to add a video resource to your project. It's opinionated and design built by experts in media and entertainment field. So we actually have a team besides myself that have been in the industry, in the media and entertainment industry for up to 10 years. And they've been doing delivery of content, both video on demand as well as live streaming. And they've taken their best practices they learned and built it in and baked that in for you to use. That being said, a lot of times customers also need to be able to customize things. So just like with the Amplify CLI, everything's written in CloudFormation, so you can choose and pull things out and add things as you see fit. So it's super easy to customize. Pedro talked about some of the ways he's customized it, and we're working on adding more customization in the future. So first thing we like to talk about is live. So this is our current infrastructure for live streaming that we have today. So we have a live source. Typically, it would be OBS or your iPhone streaming RTMP that you'd be streaming to something called Elemental Media Live. I'm not going to talk too much about our Elemental services as there's a lot of nuance between all of them, but just know that these are all managed services as well. So we pretty much stream it to Media Live. Media Live's job is it ingests that content, that RTM push, or other methods that you can push to Media Live. And then its job after that is to then transform it to Media Package, which is a real-time encoder that will then deliver it to CloudFront, or it can deliver it to Media Store as well, which allows us a lower latency and only take HLS though. So there's different methods, different paths. You can choose both paths at the same time or one of these paths. It really depends on what your client needs or requires to be delivered to. So this is kind of our basic architecture for doing live stream. We'll be talking about a better way to kind of do it in a few minutes for most of startups, as well as some lower latency options in a few minutes. But that's kind of the current one, the infrastructure that we've been sharing for a while for live streaming. For video on demand, Pedro talked about our simple way of doing video on demand. So you'll see that he talked about that video processing and hosting and distribution. We also have a content management system and metadata system as well. So you can decide if you want to add an API to your video on demand. It will then go through and set up a AppSync endpoint for you. It will set up a Lambda function to communicate back and forth, DynamoDB as well. and then also using Cognito to actually add auth to your like content as well. So it will not deliver that content unless the user is actually allowed to actually view that content. So we have a full auth system set up as well. This will actually end up using the API category and the auth category built into Amplify. So if you're adding this to your existing projects, it will actually ask you if you want to append the schema to your existing API. So it's super easy to get started and even add to your existing systems. So this is the fun one. This was released yesterday. So yesterday we announced the release of a brand new AWS service called Interactive Video Service. This new interactive video service is pretty much built on Twitch's backbone, which is awesome. So pretty much what happens is you pretty much provide a live source, and it is a black box, and then we output a low latency HLS stream straight to you. What's awesome about this as well is that you also have the ability to add Lambda functions to actually interact with metadata. So you actually send synced metadata with the video stream that actually allows you to interact with your users. So for example, if you're doing a quiz application, you can send quiz notifications or questions right alongside the video, right? So everyone that's viewing the application video will see it at the exact same time. So it's a kind of a neat way of syncing video with everyone around, so that way they all see the same content and experience at the same time. So it's really cool as well, as this is a fully managed service from end to end. You once again don't have to manage any of the servers or underlying infrastructure. Allows us to have time metadata, so we can have interactive content. This works great with AppSync. We actually are releasing a workshop later this week that will actually walk you through how to use AppSync to actually communicate back and forth with this time metadata. So that way you can actually use the subscriptions as on top of time metadata to send some awesome content through. We also have ultra low latency. So Amazon IVS can deliver video with less than 5-second latency. For those that are familiar with video, less than 5-second latency for a massive amount of stream or viewers is actually a very difficult problem to solve. For low number of people, it can be a little bit easier using stuff like WebRTC. But for HLS streams, it can be a very difficult problem to solve, which having a black box service like Interactive Video Service is a great way to kind of do so. So before I dive into a demo, I just want to talk about a little bit of roadmap items. We actually just finished video on demand support last week, so that was released. It has been in beta for about 2 months now. Yesterday, I released interactive video service support. We're announcing it officially today, so that's out in beta. You feel free to go mess around with that. I'm actually going to be showing that in the demo. We're actually currently working on some player components for the front end. So we're actually wrapping a video streaming service or a video player, as well as some video components, so that way the upload for content management system is all seamless, and other things. We're wrapping that all up, and that is currently in the works. We're also working on some video advanced settings for projects, including SNS notifications, as well as audio transcoding. There's a lot more to come, and if you don't see anything that's currently in our GitHub, or we don't talk about anything that you want us to talk about, there's our GitHub right there. Feel free to give us a star, as well as cut any issues. We're here to help you guys out as much as possible. As Pedro said, we're willing to work with you guys. So if you see anything or you want to talk to us, feel free to reach out. We're here to talk. So with that, I'm going to jump into sort of a quick demo here. So right here, for those that are familiar, we have a typical project that is currently empty. I would run Amplify status. It will give me back an empty project. So now we're going to run Amplify add video. Once that's done loading, and we're good to go. So once I run add video, we're going to be given a prompt. Elemental live stream is kind of the old live stream way to do so. This is great if you are expecting a high number of users and need a high amount of customization. Like, for example, if you are a media expert and you know what a GOP size is and other things like that, this is where you could dive into that, and this is where it becomes a lot more customizable. We have interactive live streaming, which I kind of talked about a little bit earlier. We'll dive into that in a few minutes, but we have video on demand. Video on demand allows us to name our project, and then afterwards we have a few different encoding templates. We have a default HLS adapt bitrate. This is recommended for most people. We also have a system encoding template, transcoding. This is just a 1080p with 30 frames per second, and we also have a 1080p with 30 second, just a normal 1080p with no accelerated transcoding. You also have a bring your own template. If you want to bring your own template, you can just literally download one from the console, and it'll automatically add it to your project. It'll ask if this is a production environment. If it's not a production environment, we won't add CloudFront to it. If it is a production environment, we will add CloudFront to it. This is so that way you're not having extra data egress charges. And then it'll ask you if you want to protect your content with signed URLs. For those that aren't familiar with signed URLs, it can be a very complicated process to add signed URLs to CloudFront. So we automatically stand up a Lambda function that signs URLs automatically for you and gives you that Lambda function if you don't use an API, or if you do use an API, we'll automatically integrate it with AppSync. So we're going to say yes to this. Actually, no, we're going to say no, sorry. We want to say no to that one because I don't have a PEM key that I want to sign with. So we're going to say no to that for right now. It'll ask us if we want to create a new GraphQL API. We're going to go ahead and say yes. And then right now we only support GraphQL, so we're going to choose GraphQL. We'll go through the defaults of this. We're going to choose Cognito, go through the defaults of that. For those that are familiar with API and Cognito, I won't be walking through that today, but it's very basic stuff. We're going to just automatically choose the default stuff for GraphQL again, so single object for the to-do. And we're going to say no, we don't want to edit the schema now. It will ask us if we want to override our schema. So we're going to go ahead and override our schema, and we're going to go ahead and edit it. So we'll open up our default editor, which I choose as Visual Studio Code. So what will happen is it will open up this schema. The schema was automatically generated and added for us. So it's a bot asset that has a bunch of like metadata that's associated with it by default, just title, description. We can add other things, for example, like actors, and we can add an array of strings here, and not make that not required by default. We also in here we say do not edit this type as it is required for our connection, but we can go and add extra things to our video object. If you chose off signed URLs, it will add a second field here for token that will return back that token for that signed URL later on. So we're going to go ahead and save that. We can take that back over here, and we can press enter to continue, and all resources are built. So that's awesome. We can go ahead and stack other video objects and resources next to each other. So we're going to choose interactive video streaming this time. It'll ask us for a name. It'll ask us two simple questions. First, we'll ask us, do we want type of quality of stream? HD is 1080, SD is 480. Same thing as you typically expect from your HD and SD. We'll choose HD. It'll ask us our latency type. Some people have a requirement standard latency is better for them, but we also offer ultra low latency, which is near real time, which is 5 seconds or less. Standard latency is about 10 seconds or so. The reason we chose 10 seconds or so for that is just mainly because some people want a delay in their stream, as well as those who are familiar with OBS, you can also have delays in your stream that way as well. We're going to choose that, and our resources are built. If we were to run Amplify status again, we can now see all of our projects resources are stood up. As you can see, we also will have an API resource. We'll also have an auth resource and video resources as well. Since obviously none of us like to watch CloudFormation deploy, we're not going to go ahead and do that. And we've already created a live stream resource here. So as you can see, we have a video resource already deployed. What's really cool about this is I can do a get info. Amplify video get info. And we choose our project, and we have interactive video service. We have our input URL, our stream key, and our output URL. So this is our playback URL, which is awesome. So we have all this, but what's really interesting is now you can run video setup OBS, and those that are familiar with OBS, which is open broadcast software, we'll actually go through and set up OBS on your behalf. So we'll actually set up my live stream, and we'll actually configure OBS. So if I were to launch OBS right now, which we'll go and launch, you'll see OBS here, just a very bad screen, just literally showing the time and a upside down howdy. If we actually go to settings, or we go to profile up here on the right hand side, you actually see our project name up here on the profile. We switch our profile over, we'll go to settings now, and you'll actually see in the stream that we automatically configured our stream with the server name that was defined previously, as well as our output has been already set up for the best like output resources for that stream that's been configured. So this will automatically configure it to the max settings that IVS will support. And then literally all you have to do is after switching the profile is click that start streaming. And boom, I am streaming to the endpoint and I'm already broadcasting. So if I were to go to this output, I would be able to see myself or this nice screen, and I would be able to use it. So at that point, you're off to the races and pretty easy to go. So it's a small demo of how to use it. It's very easy to use. Hopefully, if you have any questions, I'll be able to answer it. And that's all I have. Thank you. Feel free to follow me on Twitter or reach out. I'll be able to answer any extra questions if I can't answer it here.
Awesome. Thank you so much for the presentation. And I think we do have a couple of questions. And some of these are, from the attendees, and some of them might be for me if we have time. But because I'm really interested in this, and this has been, let me move my microphone a little closer. I'm sorry. This has been one of the most successful, Amplify plugins, and just one of the most successful Amplify use cases that we've seen, especially lately. So I'm interested in it. But let's go to the first question. The first question is, could the interactive video service ever be low enough latency to allow for distributed live music? Example, singers duetting over background track live.
Yeah, that's a great question. We're at Twitch, they're obviously working on lower and lower latency, and whenever those improvements are happening, they're obviously going to be reflected in the service. So eventually, yes, we're hoping that we can get stuff down to that low. I would say that at this time, probably not the best use case for it. You might be better off using something like Zoom and then broadcasting yourself over IVS to do so, instead of using something like IVS to do collaborative.
Next question, is there a lab for the IVS live stream using AWS Amplify, like a workshop or a lab?
Yes, we are going to be releasing that next week. We are currently working on adding some features to it that we felt like it wasn't ready to release as of quite yet. But yes, we will be releasing something next week, and I will be posting about it on my Twitter.
Okay, follow Sam on Twitter, and the Amplify account will try to retweet him.
Yep.
So the next question is, what are the common pitfalls to look for when doing video annotations and transcriptions?
Annotations and transcriptions, that's a great question. It's really difficult to make sure that they're correct. Depending on if you're doing video on demand content or live streaming, it depends, it kind of gives a precedence of how accurate do they need to be versus how real time do you need them to be. For like live streaming, you want your transcriptions to be like almost word for word what I'm saying, and you don't really care about correctness. But for someone that's doing video on demand content, those transcriptions should be correct. We offer some other great AWS services, including Transcribe that can do transcriptions that then you can transform into caption tracks and stuff like that. There's actually a solution out there to do so. It's Media to Cloud that will be able to kind of walk you through how to kind of do that.
Okay, next question. For Amplify Video, where is the output of the transcoding stored? Is it stored in S3?
Yes, it is stored in S3. So we have two separate buckets that we create, an input bucket and an output bucket. They have separate permissions on the buckets. So the input bucket is only allowed to be posted to by the admins of the user group. And then the output bucket, if you choose a non-production environment, it makes the objects public, but the bucket's still private. Otherwise, the bucket is totally private in the output, and you have to have a CloudFront in front of it.
Okay. We have quite a few questions, so we're probably not even going to get to all of them, but I'll shoot another one over to you. Would this work for an H.264 stream from a security camera?
So yes, if it's H.264, you should be able to support it. I would double check to make sure that what the security cam is actually outputting. And there's some other solutions as well, depending on how many security cams you need. There's stuff like Kinesis video streams that may be better for security cams as it is more built for that kind of resources. So we can dive a lot deeper into that conversation, but the answer is yes and no. Depending on your use case, it might be cheaper to go with something like Kinesis video streams.
Okay, cool. And we have a really good question, in my opinion, because I think Amplify a lot of times orchestrates a lot of services and puts them together and makes them easy to use for people that aren't familiar with tying IAM roles and maybe HTTP endpoints and Lambda functions together to create stuff like APIs. And with Amplify Video, it's tying a bunch of stuff together. So the question is, how much of this functionality is easily available without Amplify, like signed URLs, etc.?
Yes, so signed URLs, there's public documentation obviously out there. And also we're open source. Feel free to rip stuff out. It's all written in CloudFormation. It's all Lambda functions and CloudFormation. So we try to make it as simple as possible. We use nested stacks for all of our stuff. So every single resource that we stand up has its own stack. So you can literally rip out, for example, signed what's called Lambda token generator. Is what we call it for signed URLs, and you literally rip that one CloudFormation stack out and use it wherever you want. We try to make it as modular as possible, so that way people that want to go look and see what we build, it's very public and very easy to use.
Okay, awesome. Well, I think that we are kind of getting close on time, and we have another presenter coming up next. But
No
so thank you so much for presenting here, and that was a really great presentation. I think I didn't know some of the stuff that you taught about some of the other configurations. So I'm actually looking forward to trying some of this stuff out. So thank you for creating Amplify Video also. And, I'll be seeing you around on Twitter, I'm sure.
Yeah, and if you have any other questions or I couldn't answer your question, I'll be in Discord as well throughout the day. Feel free to post them in the plugin chat for video as well. And also DM me if you have any more specific questions as well. I'll be around.
Awesome. Okay, so now we're going to switch over to our next talk. And it's going to be from Ed Lima. And Ed Lima is on the AWS AppSync team. And he's going to be talking about powering applications with GraphQL and AWS AppSync. So over the last couple of years working on my team, I've worked closely with Ed, doing a lot of events and stuff in the past. And now he's kind of doing more stuff with AppSync in particular. So this should be a really good presentation if you'd like to learn more about that. So I'll go ahead and pass the stage over to Ed. I think you may be on mute.
Yeah, sorry, great, thank you.
There we go.
It's a pleasure to be here. My name is Ed Lima. I'm a product manager for AWS AppSync. Actually, I have been presented in public for over 6 months. So I started to have withdrawal symptoms. But yeah, let's go ahead. So this is powering applications with GraphQL and AWS AppSync. So what does powering applications mean? Imagine you're a developer that works with multiple data sources in different technologies, and you want to easily expose data from these different data sources to applications with a single request as easily as possible. Or you have multiple microservices and want a unified secure gateway to access specific data from different microservices, also with a single call abstracting the backend complexities for clients. Or you need to push data in real time to thousands of clients, but you're not an expert in real-time infrastructure, WebSockets, connection management, fan-out, and seamless scalability. So how can you take these and many other types of applications to new heights without worrying about operations and the undifferentiated heavy lifting of infrastructure? So you can focus directly on the application logic that will bring value to your business, as well as increase development velocity. So here's what we're going to talk about today to answer those questions. We start by quickly leveling up on GraphQL as a technology. Then we talk about AWS AppSync and how it leverages GraphQL to provide a powerful and flexible serverless API solution. We go to some different use cases and how customers are powering their applications with AppSync in the real world in production at scale. We'll then revisit some exciting features we released in the past months. Finally, we will explain how AppSync relates to Amplify and how AppSync is not Amplify and Amplify is not AppSync, but they're closely integrated. And we talk about the prime example on how AppSync and Amplify integrate to make it very easy to power applications by providing a great experience for developers with a familiar programming model, abstracting the complexities of distributed cloud systems for offline scenarios using the Amplify data store. So what is GraphQL? So GraphQL is a query language for APIs and a runtime to fulfill those queries. It's completely unrelated to graph databases, as that is not persisted in the GraphQL layer. GraphQL has both an API component to expose and access data, as well as a compute or runtime component where developers can customize their own business logic directly at the API layer. So there are two main technology choices for APIs, REST and GraphQL. Of course, there are others, but those are the most prominent today. One's not better than the other. They have strengths and weaknesses. You can definitely use them together in different parts of your application, and they're both excellent when used for the right thing. I'm a firmly believer that that you should use the best tool for the job. You don't build a house using just a hammer, and it's the same with distributed systems and applications. A picture is better than words to describe one of the main advantages of GraphQL. So let's imagine I have a blog post application. With traditional APIs, in order to fetch the data to populate my front-end user interface, I need to make a call and get a list of posts and post IDs. Then I use one or more IDs to retrieve comments. So I make a second call. Then if I need to get information about authors, I need to make another API call to a third endpoint. So in order to get the data that I needed, I had to make 3 API calls because I was either overfetching or underfetching data. So with GraphQL, I only have one endpoint and I only need to make one single API call. The data is retrieved from multiple data sources automatically for me. And these data sources can be anything: SQL, NoSQL, HTTP, doesn't matter. So GraphQL, as the name describes, is a data query language for APIs. It's also a runtime to fulfill those queries. GraphQL is expressed as a declarative language for requesting data from your application's backend. It uses a type system that allows you to understand data requirements and get meaningful error messages, making it easy to use and prototype. You define a GraphQL API with a schema based on a schema definition language, or SDL. The schema is where you define different types, such as the user type and its properties of fields, like you can see here. Using something called introspection, a client can also retrieve the schema and automatically understand how the API is documented. In the schema, you also define specific operations. There are 3 types of GraphQL operations: queries to read data, mutation to modify or write data, and subscriptions. Subscriptions are linked to mutations and allow to send real-time notifications to subscribe clients whenever data is changed by a mutation. In blue, that's what we call the selection set. The selection set represents a collection of fields you define to be returned in the GraphQL operation. And that's another powerful feature of GraphQL. The client defines the selection set it needs. For instance, if I only needed the ID and title, I can define my selection set only of those 2 fields, and my client gets exactly what it needs, and also accessing a single endpoint. So GraphQL looks awesome, right? But how's the best way to use GraphQL on AWS? Well, you could run a GraphQL server, but servers are so 2014. With AWS AppSync, you can build scalable and robust applications of the GraphQL with both real-time and offline capabilities. Best of all, no servers to worry about. AppSync is a managed serverless GraphQL service, perfect for interacting with application data. It connects to resources in your own AWS account, allowing you to make your data available in real time or offline. It can be used as a GraphQL facade to any AWS service. It also allows you to perform conflict detection and resolution in the cloud instead of doing it in the client. AppSync integrates with AWS IAM, Cognito User Pools, OpenID Connect, and you can also use API keys, providing really powerful options to secure access to your API. It's important to understand AppSync is first and foremost an application data service with real-time and offline features implemented over GraphQL with additional capabilities such as built-in authorization and conflict resolution. It's not simply a GraphQL API proxy. You can have all sorts of applications, enterprise, mobile, web, IoT, accessing a GraphQL API powered by AppSync to interact with different data sources in your AWS account. AppSync allows you to power your application with the right data from one or more data sources at global scale. It simplifies application development by letting you create a flexible API to securely access, manipulate, and combine data from one or more data sources. That can be databases or APIs. AppSync APIs can access data directly on DynamoDB, NoSQL tables, Aurora serverless databases, or Elasticsearch clusters. Applications can access everything in your account using Lambda functions, or even REST APIs with HTTP resolvers. You can easily have both REST and GraphQL in your backend. You can use HTTP resolvers to connect directly to other AWS services, such as step functions or event bridge via their regional endpoints. It's also possible to use local resolvers. Think of it as a pub/sub channel where data is not persisted. To get started, you need to model and define your data in a type GraphQL schema. As the API can be organized into a simple and understandable graph schema, it allows you to better organize and understand your data and the data flow between different downstream components of your API. We mentioned GraphQL has a built-in compute or runtime component where developers can customize their own business logic directly at the API layer. These components are called resolvers, and they provide the logical glue between the data defined in the GraphQL schema and the data in the actual data sources. Using resolvers, you can map an operation or even a single field of a type defined in the schema with a specific data source, which allows you to retrieve data from different fields in different data sources with a single API call. So let's talk about use cases and how customers are powering their applications using AppSync at scale in production. Some use cases have detailed diagrams. I'm not going to dive deep on each diagram because we have lots to cover. But at the end of the session, I'll tell you where to find the details for those most complex use cases if you're curious and want to learn more about them. So I'll start with one of my favorite use cases, real-time. So real-time technologies enable users to receive information as it happens, providing rich, engaging, and collaborative experiences. One of the most important capabilities in AppSync is built-in support for real-time data. You can use AWS AppSync to enable scalable real-time collaboration use cases by broadcasting data from the backend to all connected clients in a one-to-many scenario, or broadcasting data between clients themselves in a many-to-many scenario. For instance, we could have a Lambda function in the backend retrieving data from an external source, such as another API or service, then sending a mutation to AppSync that will update a connected data source, for instance, DynamoDB table. And then you can have thousands of clients subscribe to that specific mutation on AppSync, receiving a broadcast with the updates that are written to the table at the same time. AppSync takes advantage of GraphQL subscriptions to perform real-time operations by pushing data to clients that choose to listen to specific events from the backend. This means that you can easily and effortlessly make any supported data source in the AWS AppSync real-time, with connection management handled automatically between the client and the service. A backend service can easily broadcast data to connected clients, or clients can send data to other clients, depending on the use case. Real-time data, connection, scalability, fan-out, and broadcasting are all handled by AppSync, allowing you to focus on your application business use cases and requirements instead of dealing with complex infrastructure to manage WebSocket connections at scale. So whenever a client invokes a GraphQL subscription operation, a secure WebSocket connection is automatically established and managed by AppSync, and will remain constantly connected to your backend, allowing users to receive real-time data from any supported AppSync data source. In one of our tests with our WebSockets engine, we managed to effortlessly reach 10 million active WebSocket connections on AppSync with plenty of room to scale much more. One of our customers in the news and media business uses AppSync to enable newsroom planning and collaboration in real time. Whenever there's some piece of news developing, multiple team members can collaborate, edit, plan, write, and build the story in real time as it happens, so newsreaders can have all the facts as soon as possible. We have another customer who provides live location as a service. AppSync is a core part of streaming hundreds of millions of live location events between apps in real time, and allow this particular customer to accelerate time to market and increase development velocity, saving months of engineering effort. Now let's move on to Internet of Things. IoT devices can generate a tremendous amount of data. Analytics in the cloud and the edge turns the data into information, and this information must be delivered to users. Some use cases demand real-time access to device information as it changes. You can use IoT to access IoT device data, AppSync to access IoT device data sent to AWS IoT, for instance. You can easily build a real-time dashboard in a mobile or web application to visualize telemetry from a connected car or any other IoT device. We have a customer, automotive company in Europe, uses AppSync and GraphQL to power their in-car intelligent personal assistant. Car telemetry is ingested in the system, and an AppSync API is used to power the smart assistant capabilities and applications for an entire fleet of thousands of vehicles and car owners. What happens when applications need to deal with multiple different technologies in the backend? Your teams need to be proficient in all those technologies to work together? That doesn't scale well, right? GraphQL is agnostic to data sources technology, allowing to easily abstract them for different applications. A very powerful use case for AppSync, you can retrieve or modify data from multiple polyglot data sources such as SQL and NoSQL, or different downstream APIs with a single call. Query and create relations between those different data sources in GraphQL connections, and provide real-time and offline capabilities to web and mobile clients using AppSync as a GraphQL data layer over different polyglot backend data. Another one of our customers leverage GraphQL and AppSync to simplify large-scale data management using a GraphQL API to interact with data lakes. It's a fascinating use case where AppSync seamlessly interacts with multiple types of databases, APIs and services, and abstracts the different technologies to API consumers. AppSync GraphQL APIs can become a central hub for all enterprise data, integrating different microservices and databases. AppSync can be the Rosetta Stone for the enterprise application data, where any sort of front-end or back-end application can connect using a single endpoint and access data from any service or database in the organization, provided they have appropriate credentials with proper access controls. Now let's move to microservices. What happens when you need to expose specific data from multiple microservices? You can use AppSync as a single interface to connect and aggregate multiple microservices in your application. AWS AppSync can act as a data layer, an interface to connect and communicate seamlessly with multiple microservices, even if they're running in different environments or AWS accounts. We recently released a microservices architecture on AppSync, where a single AppSync API interacts with a REST API and API gateway, another AppSync GraphQL API, or services running on Fargate containers in a VPC. The AWS AppSync built-in features are used to securely access, modify, consolidate, route, and map data from different microservices as a single unified gateway, providing data to clients that need to be aware of a single GraphQL endpoint in the cloud. The data is correlated and linked by different services to a specific user using JWT tokens that Cognito provides for each session. Best of all, you can try this in your own AWS account with one click. It's all deployed to the AWS console, the Amplify console. An important aspect of microservices is that different teams own different services. It's important to provide a proper way for teams to collaborate, as well as make sure they don't step on each other's toes with proper isolation. You can have multiple teams working in different AWS accounts in a single AppSync API, used to securely access, manipulate, and combine data from both services. For instance, an API consumer can issue a query to get data from user feeds and profiles, while the client just needs to be aware of a single endpoint. In the background, AppSync is accessing feed data from one service and profile data from another service, routing and combining it automatically, as well as abstracting all the complexity for the API consumer that doesn't need to be aware of each different service in the backend. Teams can work in isolation in their own accounts while securely providing the data via GraphQL. With AppSync and Lambda, it's possible to create organization-wide APIs. Lambda released provision concurrency support and network improvements last year, so code starts from Lambda to access VPC resources is not an issue anymore. Front-end teams can execute with very little dependency on the back-end teams, since the back-end pretty much exposes all the data that's required. This allows front-end teams to execute faster, as they just need to be aware of the data definitions in the schema, which fully abstracts the implementation and technology requirements in the back end. So we talk about real-world scenarios and use cases where customers are powering applications with a scalable, secure, and reliable GraphQL API provided by AWS AppSync. We have customers in all sorts of industries and verticals leveraging the GraphQL advantages with improved development velocity, media, entertainment, sports, e-commerce, healthcare, transport, and education, and much more. So let's move on to a quickly recap on some exciting features our team launched recently. With local mocking, you can run AppSync locally on your laptop, model your data, prototype queries, and then ready deploy and create an AppSync API in the cloud. When AppSync was released, you could only have a single authorization mode for API. So some people had to duplicate APIs for public and private access. It wasn't possible to mix and match different authorization providers. Now you can have a global authorization mode, and you can also add multiple additional authorization providers. Most powerful capabilities to be able to assign specific providers to different types and fields of a type. For instance, I can have a type where some fields can be accessed with an API key. However, the user must be authenticated with a cognito user pool to access the email field. Best of all, you get partial responses, allowing the client to access only the data he has permissions to access. It's great as you can define security directly from my data definition in the GraphQL schema. With a click of a button, AppSync provides built-in server-side caching capabilities for any supported data source, improving the performance of latency-sensitive and high-throughput applications, and allowing developers to fetch data from a fast in-memory managed cache, delivering data at low latency. It's possible to cache the entire API data set or one or more data sources. And also, you can flexibility selective cache specific data fields that change less frequently. We released integration with CloudWatch Log Insights, allowing you to get useful information about your API usage. Log Insights enable you to interactively search and analyze your log data in CloudWatch logs. Best of all, there are useful sample queries that allow you to get started in no time. In this example, I can access the most frequently invoked operations and resources in my AppSync API. It's very useful to understand and identify hotspots. On the visibility front as well and observability, earlier this year, we released integration with AWS X-Ray, enabling full end-to-end tracing support for AppSync APIs. You can enable X-Ray in your APIs to get an end-to-end view of the entire request and visibility on the performance bottlenecks in components and modules. We talk about the development velocity and how AppSync allows to increase it. However, it's also very important to have powerful development tooling to do so. That's where Amplify comes in. Some people think Amplify is AppSync or AppSync is Amplify. We all work in the same org. As a matter of fact, if I were in the office, the Amplify team would be literally next door. We work closely together, but they're still different teams. In a nutshell, AppSync is a backend GraphQL service, and Amplify allows front-end developers to quickly configure, deploy, query, and interact with AppSync APIs in minutes. The Amplify framework provides a set of developer tools, libraries, and UI components, as well as a powerful command line interface to build and manage cloud backends, easily integrating with iOS, Android, Web, and React Native, as well as a hosting console service that deploy and host web applications. The framework allows to deploy interactive cloud services based on categories. There's no need to know AWS service concepts. For instance, don't need to know S3 provides storage or Cognito provide auth. You don't need to be a cloud architect to create an app on AWS with Amplify. As far as the framework components are concerned, the client library, CLI, and UI components are fully open source. They also manage developer services such as the Amplify console that allows to deploy and host web applications, and Device Farm, which allows to test your application on real mobile devices or browser. And these are the Amplify categories. Some categories such as data store and predictions were released late last year. And these are the two specific categories closely related to AppSync: data store and the GraphQL option in the API category. In my opinion, one of the most powerful Amplify CLI tools is the GraphQL Transform. The Transform provides a simple to use abstraction that helps you quickly create backends in your web and mobile application on AWS, all based on the GraphQL schema you define. The transforms use directives that you can associate with the types or fields in the GraphQL schema. Each directive can do different things. Add model, for instance, creates and configures DynamoDB backends, and all the business logic to interact with them from AppSync. So how does it work? Just need to define a data type or multiple types with their respective fields in the schema file. The GraphQL transforms allows to use specific schema directives. Like I said, add model directive. If I add that to my type and push the changes, the CloudFormation stack creation is started, and the GraphQL API pre-configured with all the necessary CRUD logic to interact with data in a linked DynamoDB table is automatically in minutes. But this might not be enough because calls are just authorized by an API key. So how can I improve my security posture and have proper an identity provider authenticating and authorizing calls? So I just need to add another directive, add auth with specific rules. In this case, I just want the user that created the data to be able to access and modify it. I can also specify groups such as an admin group that can have extra access. After I commit the changes and update my backend with a single command, the user pool is created and automatically configured to authenticate and authorize API calls. Now going one step further, I have a securely scalable serverless API that provides me with authenticated CRUD access to my data. What if I need to add search capabilities to my backend? For those not familiar with Elasticsearch, configuring and installing a cluster can be challenging. But if I could do it just by adding one extra line to my API type definition. So that's what you can do with add searchable. You just need to push the changes, and the Elasticsearch cluster, as well as DynamoDB streams and a Lambda function, are all deployed and configured automatically. So that is synchronized between Dynamo and Elasticsearch. So with a few CLI commands and a couple of schema directives based on the GraphQL transform, Amplify CLI created a very powerful, secure, highly available, flexible, resilient, and scalable backend in minutes. The CLI has also very handy automatic code generation capability for AppSync APIs. So CodeGen helps you generate native code based on your AppSync API for iOS and Android, as well as generation of types of Flow, JavaScript, and TypeScript. You can also generate all GraphQL statements, queries, mutations, and subscriptions, so you don't have to hand code them. There's also a directive that can be used to power your application with AI/ML, orchestrating logic to multiple AWS AI services with a single GraphQL call. So imagine I want to add image recognition to my application, then identify any text in the image, translate it to a specific language, and finally speak the text in my app. With add predictions, I just need to add these AI-related actions, and they are executed in sequence as defined in the schema. I can have an AI-enabled API deployed in minutes and easily interacting with it with few lines of code. Predictions, they leverage pipeline resolvers on AppSync. AppSync executes resolvers on a GraphQL field, as we discussed previously. In some cases, applications require executing multiple operations to resolve a single GraphQL field. With pipeline resolvers, developers can compose operations, orchestrate, and execute them in sequence. In this example, the pipeline resolvers call on recognition to identify the text in an image. Then it saves it to what's called the stash. The data in the stash persists throughout the pipeline. The text from the stash then is passed to the second function in the pipeline that calls translate to translate text, then calls poly to perform text-to-speech. All in a single GraphQL API call interacting with 3 different AWS services, saving network bandwidth and resources. Now let's move on to the last AppSync use case I want to talk to you about today. It's very useful to power modern applications, seamless offline and data synchronization support. You can synchronize data between mobile web apps and the cloud using GraphQL when you're offline, leveraging AppSync built-in support for data versioning and advanced conflict detection and resolution strategies. We released the Amplify Data Store. Let's Reinvent is a queryable local on-device data store for web, IoT, and mobile developers using iOS, Android, and React Native. Provides a programming model for leveraging shared and distributed data without writing additional code for offline and online scenarios. With the data store, developers can build highly interactive, collaborative apps that support a wide range of offline use cases. And to power those capabilities, AppSync provides built-in support for advanced conflict detection and resolution strategies. When combined to data store, developers have a single programming model where they can easily reason about consistency and data integrity, and can interact with data seamlessly, whether you're offline or online. The data store provides a persistent on-device storage repository for you to write, read, and observe changes in data locally in your application. can be used standalone without any cloud capabilities. The magic happens when you enable the cloud capabilities in the data store with a single command. If a developer chooses to sync to the cloud, the Amplify CLI uses the GraphQL schema and automatically deploy an AppSync API backend with DynamoDB tables for each type and an additional table used for Delta Sync, which is a journal that tracks the changes to the application. The data store provides a simple programming model that always interacts with local data that is automatically synchronized to DynamoDB behind the scene with built-in conflict detection, resolution, versioning, and journal. So talking about the familiar programming model with few lines of code, I can basically leverage the data store as opposed to using GraphQL. So I don't even need to know GraphQL because the data store abstracts that as well. So with AppSync, you can start effortlessly with your GraphQL journey on AWS, scales with your business, and you just pay for what you use. Amplify provides a fantastic development tooling and integrations with AppSync with the data store, the GraphQL transform, local mocking, and automatic code generation. If you're curious about the customers and diagrams you saw in the previous slides, check this link. We have presentations and videos from each one of them explaining the architecture and how they're powering the applications with GraphQL and AppSync at scale. AppSync helps your application to get there. Thank you very much. I think I'm a little delayed on time, but it just made it 30 minutes.
All right. Yeah, that was really great. I mean, I think we hear a lot about AppSync and we hear a lot about Amplify. And I think that some of your discussion around, where they fit in, how they work together, and all of that was really helpful. But also, I think a lot of the stuff around GraphQL is not really, known to people just coming into Amplify that haven't worked with GraphQL a lot. So a lot of that explanation was really helpful. And we do have a little bit of time to take a couple of questions. So let me go ahead and pull those, and we'll do a few. I know we're not going to be able to get to all of them, unfortunately, but we will try to get to some of them. So the first question is, or it's kind of like a comment. So AppSync is like a middleman that syncs all of the updates for every single action to the client database that's subscribed to this middleman. Like that's kind of the question.
If you're using the data store, yeah, you have a local database on device or in the browser, and AppSync basically provides the capabilities to synchronize, to provide conflict detection and resolution, and also version the data. Yeah, that's correct.
Okay. Yeah. So I mean, the real-time piece is kind of optional. You can use them or you don't have to use them. It's more like they're there if you want them, and it's super easy just to kind of add them in because they're already actually implemented on the back end.
That's exactly
so.
Right.
The next question is, I don't know if this is something you can talk to, but what are the high priority features in development for AppSync that customers have asked for?
So we are working on lots of things the next 6 months. One of the big one is the programming model. So we are looking into adding, we currently using BTL for our resolvers, but we're looking into adding an additional programming model. And for now, we're thinking about JavaScript, TypeScript, because it's the most requested programming model. So it makes it a little bit more easier for developers to reason with and test and deploy. We're also adding some very interesting capabilities with our Lambda resolvers, so stay tuned in a couple of weeks. And also we're adding some important security features as well in a couple of months.
Okay. The next question is the real-time update of every event sent to all of the clients that subscribe to it?
You can choose to do so, because when you configure a subscription to the client, you can define arguments. So only if those arguments are fulfilled, then the client receives the subscription. So you can do broadcasting to all clients, or you can basically filter that using arguments.
Yeah, a very common use case for there would be something like when you have like a relationship, like a many-to-one relationship for something like a post with comments or a message within a message room or a room ID, and then that ID would be like the subscribed clients would just need to pass that ID into the argument. Of course, you could also subscribe to just the entire application if you wanted to the entire type, but that's kind of probably a less popular real world use case. You're typically in a real world application going to have some type of arguments. So does AppSync able to, I'm sorry, go ahead.
I just want to say every single day customers come to us with the different use cases that I never anticipated. So it's really cool. There's always people using AppSync in different ways.
So is AppSync able to support custom Cognito authorizers?
Custom authorizers, this is one of the features we are working on in the next couple of months. Stay tuned. So we are definitely working on that with high priority.
And I think the last question that we're going to unfortunately be able to answer, we're not going to be able to get to all of them, is will we be getting more directives to match the data sources available through AppSync? I'm not sure exactly what they mean by that.
Yeah, I'm not sure.
Oh, okay, maybe for the other data sources like I guess RDS or Elasticsearch maybe.
Yes, we're planning on expanding the additional data sources. We can already access them with Lambda. We're going to make it easier in the next couple of months or weeks. But definitely, yeah, we're planning to do more. Yeah.
Okay, great. Well, I think that's it from Ed. So thank you so much. That was really great, and thank you for presenting, with Amplify Days today.
Thank you. It was a pleasure. It was lots of fun.
Okay, so next up, we have a really interesting talk that's going to kind of expand, I think, on what Ed just presented on by Brice Pele, and he's going to be talking about using the GraphQL transform library. And it's going to be a really interesting talk. This is actually one of my favorite subjects as well, so I'm really looking forward to hearing this. So welcome to Amplify Days, Brice. I think your audio. Sure, no worries, no worries. I might take a look at some of these other questions and see if I might be able to answer. So one of the questions from Ed was, is there support to use the GraphQL transform library with the AWS SDK, or will they be in the future? Actually, someone open sourced a library that actually does this, but as of today, we're not really planning on building anything specifically for the AWS SDK. But because the CLI is open source, you might be able to just take some of our existing functionality and implement that yourself. Or maybe this open source library is something that's going to kind of continue to be supported and stuff. So I would take a look at that. Hopefully, I can kind of look up a link and maybe provide that in the chat in just a moment. Brice, any luck on the audio? There we go.
Yeah, can you hear me? Okay, awesome.
Yes. Okay, cool. I'll go ahead and step off then and let you go ahead and take it from here.
Awesome. Thank you, Nader. And thank you for having me. Really excited to be here and to talk a bit more about Amplify and transforming GraphQL and some of the stuff that's going on there. So just real quick intros. My name is Brice Pele. I'm a principal mobile specialist solution architect at AWS. A bit of a mouthful, but essentially I'm a solution architect that works into mobile space. I help our customers that are trying to implement solutions on top of AWS for mobile, for web, using some of the services and tools that people here are mostly familiar with, like Amplify, AppSync, Device Farm, and so on. So what I want to do today is talk a little bit about transforming GraphQL and talk a little bit about what that means. Really what we're going to do is look at what Amplify really is. I'm going to just kind of give a quick overview, look at the GraphQL transform and how that can help you as a developer do data modeling for your own application. And then we'll do a little bit of a demo, I guess, just to run through what it actually looks like to to communicate with an API and to interact with an API that has been creating using some of the capabilities provided by Amplify and to GraphQL transform. So just a quick overview about AWS Amplify, maybe for some that are not super familiar with what Amplify is. So we really built Amplify, as the name kind of suggests, to amplify the development process for front-end engineers and full-stack engineers. So the history behind Amplify is that we really wanted to be the fastest way to develop mobile and web apps at scale. And some of the things that we want to make really easy for developers is, to get started quickly, of course, but then to take your ideas to market quickly. We want to focus on the innovation part, right? There's a lot of kind of table stake stuff that has to be done when you're building an application. And, we want to enable developers to take care of those things really quickly and then to move on to the things that actually set their applications apart, right? So to the differentiating features of their own applications. And then we're built on top of AWS. Amplify is built on top of AWS. So whether you're starting with 0 or to 100 customers, or whether you have 1 million customers, right? If you go viral, we want to provide performance that scales. And we do that because we are deploying your resources on top of AWS, which is a proven solution. So we want to make Amplify easy to use. We want to make it available to multiple frameworks. So on the JavaScript side, if you're building any kind of JavaScript-based application, it'll work with that, with a lot of the frameworks that are out there like React, Angular, Vue, Ionic, and others. We want to provide UI components. You've probably seen some of the ones that we provide onto Offspace, just to make it easy to get started and to implement some of the security features that are really complicated but needed in most applications. And then we want to provide comprehensive features, right? So anything that you need to do your development, integrate with APIs, integrate with storage, and with the other managed services that are available on AWS. And then, of course, it's built on top of AWS, so it scales, it's available, and it's really secure. And we do a lot of this by taking a lot of the best practices that we've learned over time at AWS, and we kind of bake that into the solution that Amplify offers. So it's a great way to get started, and really a set of tools that you can trust to go from 0 to kind of hero in a short amount of time when you're building an application. So specifically, if you look at Amplify, it's a set of tools and services. One of the great things about it is that you can pick and choose the components that you want to interact with when you're using Amplify. So it's made up of a framework. So the AWS Amplify framework is a set of open source tools. So you can go on GitHub today and look up Amplify CLI or Amplify JS, Amplify iOS, Amplify Android. And they're open source libraries, right, that help you get started and help you manage your resources into cloud. So you've got the CLI that helps you manage those resources into cloud and easily configure resources, update them, manage them, delete them if you need to. And then you've got the libraries that you can use to actually interact with those services easily. And you don't necessarily need to use the CLI and the library together, right? You can use them separately. They're individual components, but you can choose to mix and match, and the CLI and the library work really well together. We then also offer a hosting service. This is the Amplify console. It's really a managed CI/CD, specialized CI/CD offering that allows you to build and deploy your web application onto cloud, and to do that at scale. One of the things that we'll be talking a lot about today is AWS AppSync and AWS Amplify. So AWS Amplify supports an API category, and in that API category, it allows you to easily manage an AppSync API, deploy an AppSync API, and then interact with that AppSync API. So it's kind of a match made in heaven when it comes to interacting with this managed GraphQL backend that is AppSync. Amplify is a great tool to use, and we're going to really dive deep into some of the functionality that it provides to help you do that. So specifically, talking about Amplify CLI, it's really easy to get started with it. Like I've already mentioned, it allows you to create, manage, and deploy AWS services. So to get started with the CLI, it's very simple. First of all, you want to install it. It's on NPM, and you can look it up there. And then when you get started with a project, you want to amplify your project, right? So you do an amplify init, and that kind of sets up some basic configuration, basic resources that you need to get started. Once you've done that, you can do something like amplify add API. And then it'll walk you through a series of prompts. And that's one of the strengths of the Amplify CLI. It's really intuitive, right? So it allows you to not know every single thing about the backend resource that you're deploying. What it does is ask you a series of questions, and then based on your answers, it deploys those backend resources using some of those best practices that I've talked about, making sure that it's secure, making sure that it's well managed, making sure that it's scalable. Then you can do push to deploy your configuration, and then at any time where you need to actually make an update, you can call Amplify Update API. So that's the CLI in a nutshell. Then on top of that, it provides some pretty interesting functionality around the API. We've got the API GQL compile command, which I use quite a bit when I'm writing an Amplify schema. I can call this command to compile my schema and to see what it actually looks like as a fully deployed GraphQL schema. We also have the Amplify mock feature. This allows you to do local mocking. So as you are in the midst of your development cycle and you're testing out your schema and you want to make sure that it works well, right? Deploying those changes to the cloud, can take a bit of time, right? When we're developing and iterating, we're looking for some of that quick feedback. So launching this Amplify mock, this mock server allows you to get that quick response, that quick feedback, and allows you to make changes where you need to make them. And then if you're working on teams, or even if you're working and trying to test multiple environments, we also provide multiple environment support by using the Amplify ANV series of commands. So that's the Amplify CLI real quick overview in a nutshell. Okay, so now I'm going to dive into the GraphQL transform library, right? It's essentially a library that allows you to write custom GraphQL directives and helps you quickly add functionality to your API. But I guess the first question to ask is, why do we need to do this, right? Why the need for this library, for the GraphQL transform? And I guess the question to ask is a little bit, we talk a lot about data modeling, but it's worth asking, like, what is it? And why do we do it? From a high level perspective, data modeling is nothing more than kind of the diving deep and analyzing data structures, right? Analyzing how you interact with data and then how you need to deploy that data. When you look at it from the perspective of front-end engineering, the idea is that you really want to understand your front-end client requirements, right? So you want to understand how your client behaves, how it interacts with data. And then you want to be able to capture those requirements into a conceptual data model. Right, and so you have tools like UML and other type of tools that are available to do that. And it's really important because when you've got that conceptual data model, you may then make it easier to communicate with others, with other team members, what you're actually trying to put together. It actually makes it easier for you to understand what is going on because you've captured those requirements conceptually, and then you've got a language that you kind of understand that expresses what you're trying to do. But then the last part, which is really the difficult part, it's translating that model into a physical or logical system. Okay, so you've got a representation of what you want to do, but where do you go from there, right? How do you actually turn that into something that's usable? How do you iterate quickly on that? So the goal really is to ensure that your backend system can handle the data that your client interacts with. And you also want to enforce the business logic that governs access to that data. It's really important, right? So we've got the data, but how do we access the data? Who should be able to access that data? And typically the steps, it's kind of an iterative process, right? You want to start identifying the types, the fields, the connections between the types, right? And then you want to identify the access patterns and the security restrictions. So there's a lot going on there, and it can be hard to get right. Even if you get the first part right, which is just kind of understanding requirements, which is not necessarily a given, the last part, which is, turning that into a full system is really hard. And that's where Amplify really comes in to help you with that. So the GraphQL transform, what is the GraphQL transform promise? What does it offer you? Well, it allows you to go from a schema to a fully deployed, full-blown infrastructure via data modeling. So you start with what I would call an Amplify schema. So you use the GraphQL schema definition language, the SDL, to write your types. So we're starting with something that's fairly well understood. If you know GraphQL, it has a SDL, and we can start there. And then we can add annotations and decorate it with directives that actually specify where that data is supposed to be backed up, right? which data store to use or data source to use to back up that data. And then we can also specify to rules that control access to that data. We can then do something like GQL compile, which will turn that schema into a set of CloudFormation templates and other assets, right, needed to construct our application. And then by doing something like Amplify push, we actually get to deploy those sets of CloudFormation templates into resources that are deployed in AWS. So we've gone from a simple schema, well, it could be more than simple, it could be complex, but it's a schema, to a fully blown, fully deployed set of resources deployed in AWS. And so what that's going to be, it's going to be an AppSync API that has data sources that have been deployed based on what you specified via the directives in your schema. So the GraphQL transform, it's like I said, it really tries to add directives to add functionality. It really amplifies your API. It allows you to create model relationships, to create models and then relationships, to add authorization rules, to create the data sources that are going to save that data, and then to create schemas, the schema that allows you to actually access that API, right? And then you can do complex things like creating DynamoDB global secondary indexes and sort keys. You can create Lambda function resolvers. You can create HTTP resolvers, which is one of my favorite directives, actually. So there's a lot of things that you can do. So these are all of the directives that are supported by the GraphQL Transform library today. And what we're going to do today is really focus on the ones that are most closely related or associated with DynamoDB backends. So that's going to be the model, the auth, key, and connection directive. So we're going to set aside the function, searchable, and prediction HTTP directive for today, but we could do a whole separate talk about just how you could put these different directives in play when you build your APIs. So let's dive into some of what is going on here. So let's look at the model directive. So the model directive is fairly straightforward. When you use that directive to annotate a type, it essentially states that that type should be stored in a DynamoDB table. So you add to model, and when you push your definition, it creates a DynamoDB table to store that model. And then given the ID that you specified, by default, it uses an ID, and it will create a DynamoDB table with the ID as the primary key to access that table. So when you use the model, you can actually specify how the queries are supposed to be created. You can specify if you want queries or not. You can specify if you want mutations or subscriptions. You can turn on the subscriptions. You can make them public. So there's a lot of configuration that you can do there. But you know, at the root of it, it takes your type and states, I need to back this type in a DynamoDB table. Then you've got connections. So a lot of time you build an applications, you're going to have multiple types, and you're going to have multiple types that interact with each other. So a connection allows you to connect two different models together. So here I have an example where I have a type album. So, you know, as the name suggests, the album is like storing, or the top level element that stores my collection of images. And I want to tie images to my albums. So the way I would do that, I would simply specify a field called images, and the type would be an array of image. And then I would specify connection. So this is kind of pseudocode, but you see what's going on there. It's going to create a connection between your album and your image. And what ends up happening essentially is you're going to have two tables. These are created via the model directive. And then by adding to connection, Amplify is going to run some logic, and it's smart enough to figure out how to tie the two tables together. And most of the time, what is going to happen here behind the scenes, you're going to have a global secondary index, and you're going to have an album ID here. This should be a field that exists in image, and the album ID is going to be used to fetch the images that belongs to the particular album. Then you've got your auth directive. So the auth directive essentially allows you to specify the rules that governs access to your data. So here you can see that I have a DynamoDB table created because we specified the model, and then I've specified an auth rule with the allow owner rule. So this is one of the most basic but most powerful rules that you can specify with the auth directive. What that does is that it specifies that only the owner of a specific album is allowed to read it, update it, or delete it. And it does that by introducing some logic into resolvers that checks for all operations that the owner field that is associated with the album matches the identity of the owner as specified by the by Cognito user pool. So when you sign in with Cognito user pool, you're going to get a JWT token. That JWT token is going to have information about the individual. It's going to have a username. It's going to have a set of groups. And here specifically, what we want to do is make sure that the identity matches the field that has been set for this album. So this is one of the core strategies that you can use and really helpful when you're using DynamoDB and Cognito. But you can also specify other strategies, right? So the other strategies are groups, if you want to allow groups to have specific access. If you want to allow a whole authorization mode, like all of the Cognito user pool users or all of your IAM authenticated users to access something, you can use private. Now, if you're using something like an API key, you can specify a public strategy. And then, if you have you can have a mix of and match of these rules, because as you probably heard in the previous session, AWS AppSync supports multiple authorization modes, so you can mix and match them and use them at the same time. So if there's any ambiguity between the different strategies that you're employing, you can specify to provider. So maybe I want to do something private for my user pools, or maybe I want to do something private for my OIDC provider, or something private for IAM. So I can specify this with this off provider enum. And then last but not least, we have the key directive. This is a really powerful directive. The key directive is essentially going to create a global secondary index for you in the backend. So this is really useful because DynamoDB essentially is a key value lookup system. So DynamoDB is great when you have specific key or specific range of information that you want to retrieve. So as you're doing your data modeling, you really have to think about, like, even if I have a set of albums, how am I trying to access those albums? And then you've got to model your data based on that, right? This was kind of the first step, understanding how your client interacts with the data, right? So you may have a situation where we are storing our albums in a DynamoDB table and indexing it with a primary key set to ID. But that may not be the most efficient way of retrieving albums for all use cases. In that case, you want to use the key directive and create a global secondary index that will allow you to retrieve albums or items in a specific way. So it's kind of looking at the data set from a different perspective and fetching and narrowing on that data using the key. So here, for example, we're creating a key with a name by status and date. We're setting the fields. We're using the fields to create the key. Owner, status, and created that, and we'll talk about that in a little bit. And then we're also telling Amplify to create a query field so that we can actually use this key, and it will create the query fields list by status and date. So what are the specifics about the key directive? Well, this is the definition of the key, and it takes in a couple of attributes. So the first one is the name. So this is optional, but there's a bit of a caveat to this. So you can specify a key without a name, but you can only specify one key without a name per type. If you specify the key without a name, it will actually use that key as the default key for your table. So instead of using ID, you may have a more relevant key that you want to use. You can specify to use that key instead without using a name, but you can only do that once. Then you specify the fields. So the first field is always going to be your partition key, and this is required. So the partition key is what starts the narrowing process. So you're essentially saying here, I want to have a partition key that allows me to fetch my album based on the owner. Then you can specify your sort key. This is optional and can be one or more fields. What Amplify is going to do here, it's actually going to concatenate the value of all those fields to create a key. And this is pretty interesting. It allows you to narrow into specific queries. And then, like I talked about earlier, you can use the query field to specify whether or not you want Amplify to create this query field for you. So if you have an owner, you can start, and if you have an items with owner status and created that, this will create a primary key with owner set to Brice and a sort key with status created that, and it's just going to concatenate the information. So what that allows you to do is to use the keys to narrow your queries. So you can start by searching by owner, you can then choose to search by owner and status. And if you want to, you can search by owner, status, and date. So that's pretty powerful when you want to narrow down your queries. And you can see an example of that here. So I'm specifying that I want to search by owner, and then I want to search for everything that's been created between 2019 and 2020 that are private. So that's pretty powerful if I want to narrow down my queries, and that is done really efficiently on the DynamoDB side. So let's say we have an application. It's an album application, right? I kind of hinted at that we're trying to build. It's an application that has a set of albums, and in each album you have images, and you want to retrieve albums in specific ways. So some of the stuff that you want to do is you want to retrieve album for a specific owner. So to use the application, you log in as an owner. You want to have shared album, your top 10 albums, which are your album with most images, your latest albums, and you also want to be able to retrieve all images and favorite images. So how do you go about doing that? Knowing that you have a lot of albums, and as you can see here, you may have to paginate through all of these albums. So the first thing that you're going to do is you're going to create an album type, right? And you're going to set a rule to it. Your rule is allow owner. You're going to specify the ID, to name, and to owner. So this will create an album type and restrict your access to owner only. The first thing we want to do is fetch albums. So what we're going to do is create a key, give it a name by owner, and specify the fields. So the primary key is going to be owner, and the sort key is going to be name. And then we want to add the query field, list albums by owner. So this is going to allow us to fetch everything that belongs to an owner. So if I want to fetch everything that belongs to the user Brice, I can just specify that here and set the sort direction to ascending to get all of my albums sorted by name returned to me. One thing to remember is when you do these queries, you always have available a filter, sort direction, a limit, and a next token. Be mindful of filter. Filter is not super efficient. Filter is run after your query has been done on the DynamoDB side and kind of more done on still on the back end, but after the query has been done. So you want to be careful when you apply a filter. So what if I need to fetch my top 10 albums? Well, I'm just going to add another key, and this one is called by image count. Again, it's per owner, but I want to index based on the image count, and I want to add the query field list by side. And then what we can do in our query, we can start by saying, well, get me all of the albums that belong to this user, and get me everything with an image count that's greater than 50. So we want to get everything that's greater than 50. This is one of the key conditions that we can apply on the query that we're doing on the DynamoDB side. Then I specify the sort direction, so I will get everything in descending order. So I will get my top albums first, and then I set the limit to 10 because I don't want to get more than 10 albums for this. So again, this is another use of the key. It's pretty powerful. You can use the condition input to get this done. Now, what about sharing albums, right? We started and we set this up as something that is private, right? So the way to do that is we're going to have to allow users to read public album using a group auth rule. The next thing we're going to do, we're going to add a key on the type to easily fetch the album. So we only want to fetch things that are public with this request. And then we're going to add a field to indicate if the album is shared or private. The last thing we're going to do for this application, we're going to make sure that all users are part of a public group. So if an album is marked as public, all users will be able to get that album because they are all part of the public group. So how do we do that? So the first thing we do is add this auth rule with the groups, the status, and read. So what this is a dynamic group rule that says anytime we want to access anytime that we want to access an album, we need to make sure that this field status contains one of the groups that the user belongs to. We then add the key by status, and we set the field. The first field is going to be status, right? And status can either be public or private. So when we want to query on using this key, we're going to be able to say, get me everything that's public, and that's going to be pretty efficient. And then we're add the name here so that we can sort the albums by name. And then finally, we add the status field with the share status. So the albums can either be public or private. And the status is going to be private by default. So by default, when we create these albums, you cannot access the album. So what does that look like when we want to fetch something? So it's going to be pretty efficient because we are querying with a key, and we're only returning to fields that are public. And then at the same time, before returning to fields, our logic that we've put into resolvers are going to make sure that only albums that have been set as public are returned to users that are part of the public group. So pretty powerful. Then the next thing you were going to try to do, and I'll go through this quickly, is set the connection between our images. So we're going to create an image here with a model. We're going to turn off the queries because we don't want to access images directly. We only want to access images via a model, and we're going to set the rule to owner. And then using connections, we will be able to access the fields. So now we're going to take everything that we've learned about keys. We're going to define a key here by album that indexes everything based on the album ID. And we're going to create a connection on an images field that's of type image. And we're essentially going to say, to fetch the images, use this key onto image type called by album, and use my ID as the partition key when you return to album, right? So that's how we can actually efficiently fetch a connection. And then we can do the same thing for featured images, but this time we are going to use an additional field that specifies whether or not an image is featured. And this helps if we need to have an album, like you're showing an album and you want to have the featured albums on top on the main page. This is what you could use it for. Okay, so this is essentially what I had to show about using keys and data modeling. If we want to take a quick look at how you can actually go and test this out, I have a mock server that I'm running. So I started this by doing Amplify mock, so I don't even really have to go to the console, and I can just come in here and kind of test out my data modeling. I don't have to push this to the cloud yet. So let's say I wanted to get all of the shared albums, right? What I did here is I went and I'm using this mocked user called Brice. I have a public group and I do generate token. So it's going to use that information to fetch my data. And let's say I want to get a list of shared albums. I can come in here and I can say that I want everything with status public. Not going to specify anything for the name, specify the items. I want to see the name, the owner, and see the status. Let's say we do it like this. And you can see that I'm getting everything. There's another owner here called John, but I can get his data because it's public. So this is one of the ways that you can actually put the mock server at use when during your development cycle. So there's a lot more that could be said about using the keys and the data modeling, but hopefully this was really informative. The data modeling and the GraphQL transform really helps you iterate quickly and build models that scale and that represent what your front-end application does with the data and how it interacts with data. So hopefully this was interesting. Feel free to ping me on Twitter or into Discord if you have additional questions about data modeling with the GraphQL transform.
All right. Thank you so much. That was really great and very in-depth. We will try to cover just one or two questions because we're running a little bit over on time. But I guess the first question is, are there GraphQL transform directives for using storage other than DynamoDB, for example, MySQL? And there are two questions around that. So.
Not right now. We do. I mean, the Amplify library does offer a couple of commands that you can use to set up. Like if you want to use an Aurora serverless, we do have a couple of commands that you can use into CLI to actually help you set that up. But the DynamoDB right now model is the main one that we support. Then we also support searchable, that will stream your data over from DynamoDB to an Elasticsearch cluster. So if you want to do things like fuzzy searching of data, you can use that searchable directive.
Got it. And I think Ed mentioned that they're on the roadmap hoping to add support for a SQL database, probably serverless Aurora down the road for the GraphQL transform library. Right now, it just isn't there. And then the next and last question that we can get to is there a way to specify auth roles for specific operations? For example, different permissions to read than update?
Oh yeah, you can definitely do that. So you can specify, so we have an operations field that you can specify into rule in the auth rule, and you can specify read, update, delete, create. So you can be pretty granular with the rule.
Awesome. So I think that wraps it up. So again, thanks, Brees, for the presentation and for presenting at Amplify Days. And we're going to now go to the last presentation for the day. And we're going to be having Nikki Stone and Kyle Lee. And you've probably seen Nikki as part of this event so far a couple of times. She's been helping, do the introductions, and she was part of the panel kind of stuff that I'm doing yesterday. And she is an engineer on the iOS team for Amplify. And then Kyle Lee is a fellow senior developer advocate on the team that I work with. And he's also a specialist in iOS. And they're going to be talking about the new native iOS libraries that we released for Amplify recently. And yeah, I'll go ahead and let them take it from here. Who's going to be presenting first between the two of you?
I think it's going to be Nikki. I think you might be on
cool.
here.
Oh, wait,
I'll go ahead
Kyle.
and share. I'll go ahead and give you permissions, Nikki, and then we'll go ahead.
It's all going to be presented on my screen, though. Sorry.
Okay, perfect. That's all I need to know. Okay, I'll go ahead and jump off then and leave it up to you two.
All right. Hi, everyone.
Let me see.
I'm sure you know me by now. If you don't, I'm Nikki. As Nader mentioned, I'm a senior software engineer here on the mobile SDK side of things, specifically focused on all things iOS.
And I am Kyle Lee. I'm a developer advocate here at AWS, focusing on Amplify and playing with all the cool stuff.
We're going to run through these slides really quick because we want to get to the cool part of our talk, which is the live coding. So if you have a lot of questions, feel free to shout them out during. I'll be watching the questions as we're going. And I'm pre-apologizing for how fast we're going to run through these slides. Okay, so agenda for today. What is Amplify? Who should be using it? And then we're going to dive right into some code. Okay, so again, really quickly, for those of us that aren't familiar with Amplify, Amplify makes up 4 different things. It's a CLI, consoles and libraries in the languages that you know and love, and the frameworks, and then UI components. It's use case based, so it's based on categories, and it's not service based, but the services act behind the categories. So if you go to the next slide, Kyle, very simply put, you might do something like Amplify add auth, and then you might use that authentication in your code using one of the libraries like you see on the right-hand side. Move on to the next slide. I think I have like some delay on my side, so sorry if I don't talk until.
Oh, no problem.
Okay, so I really want to touch on Data Store really quickly. Data Store is one of the coolest things that we launched at reInvent, this past reInvent, and it is multi-platform, so you'll find it on any of our platforms. It is device persistent storage engine. This is something that mobile developers have struggled with for so many years, endless amounts of time, and now it will automatically synchronize your data locally between your device and the web, if you have a web app and the cloud, all using GraphQL. It's got amazing capabilities like auto merge and Delta Sync. I highly encourage you to dive deep on Data Store at a later point in time if you don't know all the features that it offers, but we will be using it today and demonstrating it in code. Next slide. Okay, so these are some of the categories that are offered by the different platforms. You can see iOS and Android are a little bit behind. They do now have auth, so this slide is a little bit out of date. But we are working hard to catch up to JS. JS just came first before Amplify Native. So at reInvent, we launched with, I think, 5 categories, the ones that you see there: API, data store, storage, analytics, and predictions. And then we've since released auth before we went GA, which was in May. And then we're working on other categories now to launch for you, for our native folks out there. Cool. Next slide.
All right, so I think it's my turn to get into it. So let's go ahead and get into the craziness that is live coding. And
the GIF perfectly represents the act of live.
Exactly. All right, so let's just make sure we can see the font. Yeah, is it good, or should it be bigger? Let's do bigger.
That looks good to me.
All right, good. All right, so we're gonna kind of be starting from scratch. I just want to show you the app that it is right at this second while it's loading. Essentially, all it is just this. It's going to be this sign up button that we're going to see right here, and it's actually, it doesn't have anything attached to it quite yet. So all I'm going to be doing is I'm going to be going through using the docs, because the docs for Amplify are super amazing. We're going to be using the docs to actually get everything up and running, and it looks like I already have a problem right here. So let's go ahead and fix that. But yeah, so we should be able to get up and running. There we go. All right. So I'm going to be using the docs in order to get everything that I need to do pretty much thrown into the app. So first thing that we want to do is we want to get going with auth. So I'm going to go over to authentication, get started. And I already did some of this stuff. I already did like the add amplify, all the console stuff, so that we can kind of get into the meatier parts. I also did the CocoaPods, which is the dependency management system that we're using. And now what I want to do is I just want to make sure that I have Amplify in my project. So what I'm going to do is I'm just going to import the Amplify frameworks right here. And the awesome thing about these docs is that they're so easy to read that you can literally just copy and paste. And that's what I'm going to be doing a lot of today. So
that's real life coding anyways, right? That's what y'all do on a daily basis.
Exactly.
Anyone that thinks otherwise is
yeah, you don't even have to go to Stack Overflow right now.
there you go.
Okay, so as you can see, oh, actually, let's clean this up so it's a little bit sexier. So what I'm going to do is I'm going to have a function called configure amplify, and that's going to hold all my code that has to do with amplify, right? So we'll have this do catch, right? And we'll just
like the lack of app delegate.
Oh yes, and also to inform anybody that wasn't aware, I am using like the latest beta of Xcode. So if anything can go wrong, it will go wrong. It's definitely Murphy's Law right now. So we're gonna see how far we can get. And I could actually copy to all of this. I could have just copied it.
I'm gonna provide entertaining commentary as he live codes.
Usually what you can actually see is like did finish launching with options. We're using the brand new Swift UI way of creating apps, which is just like you conform to this app thing, and now you don't have to do any of that. So this is a new way of doing it. So now, as you can see, what I did right here was I added this plugin, which is for our auth. We're going to be using Cognito auth plugin. And as long as we're able to configure and we're able to add this plugin, then we should get this printout right here. So let's go ahead and make sure that this is going to work.
Do you have to call it for a minute?
Oh, I absolutely do. That's like one thing that I always forget to do.
Got your back.
Love it. And we also,
I'm not familiar with this new setup anyway, so that was actually a general question. I didn't actually know the answer to that, but I was pretty sure.
Okay, so let's see if we get the printout. Oh, and it looks like it actually didn't print out anything. So let's make sure that we are running it with the configure amplify in the init. There we go, amplify configured auth plugin. So we're already one step of the way down. So let's just go over what's going to happen in this app. What we actually are going to do is we're going to be working with photos. So we're going to be signing in, then we need to upload a photo, and to save it somewhere to like S3, right, we're going to be using the storage plugin. Then what we're going to do is we're going to hang on to a reference of that photo as an object in our database, which we're going to be using DynamoDB, and that means that we're going to actually have to have the API plugin. So let's go back over to the docs and let's make sure that we grab all of those all those things that we needed. So we needed the data store and we needed storage
plugin, the API plugin, and the storage plugin. Is that right?
Yes. So as you can see, I'm just once again going to copy from the docs. I need this line right here, and we'll throw this in. So that's S3 storage, right? So now we need the one for API. So as you can see, what we're going to do is we're going to grab this one right here, And we will also be throwing that in there. And let's see. Okay, so we have the data store plugin, we have the AWS S3 plugin. We also need API. So it seems to be in this API GraphQL, and we will scroll down, and this is the one that we want right here. So it's always lovely when you have docs that actually show you exactly what you need to do and how easy it is to do it.
Totally.
And let's just make sure that we're using the same instance. It doesn't really matter because these are structs. For those of you that are not familiar with Swift, struct is just like a data class or something like that.
Struct is a value type. So
yeah, it's a value type.
Not a reference type.
But they will be the same value, so it wouldn't really matter. But hey, let's try to make it a little bit sexier, right? So now let's go ahead and run it. Let's make sure that we have all of our plugins being added right here, and we should still be getting this printed out. And we do. Amplify configured auth plugin. All right, so we already got all of our plugins put into place. So now what we need to do is we need to make sure that we're opening up our auth view and we're actually signing in. So we're going to go back over to the auth area. And what I want to do is I want to copy this function right here. So I want to fetch the current user for the session. So let's go ahead and jump in there.
It's a pretty normal thing you're probably going to do in every app.
Yeah.
Building off
Yep.
into.
Yeah, because you want to know if the user's already inside of the app so that they don't have to keep signing in, right? Like nobody wants to do that. That'd be kind of lame. So as we can see, we have this fetch current users session. So what I'll do is when this view appears, what we're going to do is we're going to call it. So on up here, we're going to perform fetch current auth session. So let's go ahead and do that. And that will let us know, are we signed in or not? So as you can see, the function calls or like the APIs for each of the Amplify libraries are pretty much set up all the same. And what you're going to see is like you're going to be receiving a result in a closure, or you could think of it as a lambda, and you'll have a result and you can switch based off of whether it was successful or whether it was a failure. So we have a lot of logs in here. So what I'm going to do is I'm going to search for this specifically. And is user signed in? No, they are not. So let's go ahead and sign them in. And I can set up a whole entire auth flow by just simply adding this function right here. So let's go ahead and add an entire auth flow to our app with this function right here. And let's see, so we want to change this to window. Good thing I'm already inserting a window. I did cheat a little bit. There's a little bit of helper code in here. So I am passing a window into this auth view before I create it. And we're going to present in that window. Now, one other thing that I need to make sure that I do, this right here in our info.plist. So in our configuration file for our actual app, we need to make sure that we add this in here so that the web view knows where to return us to. So let's go ahead and add that in there. I think I may actually already have added in. Yeah, so I already actually have it in here.
Nice.
But if it wasn't in there, make sure you follow that step or else it won't work.
Good call
So
out.
I don't think I called it. Let's see. So if we are not signed in, let's go ahead and add some logic. If we're not signed in, then let's make sure that we're going to make the user sign in.
I'm majorly hating my internet today for the lag time on watching you live code. Like,
yeah, I'm actually experiencing some lag on my own side, which is pretty weird. Like my computer's starting to slow down. It's like it's too much. I feel like
watch you type if, and then like I don't see the rest of it for like another 20 seconds.
Oh man. Okay, so if they are not signed in, right? So if session is signed in, then you know, we'll do something, and we'll cover that right now. But if not, then we're going to sign them in. So when this is called, we're going to run through. We're going to see that is signed in is false. We're going to hit right here, is sign in with web UI. It's going to call this right here. From there, I also want to make sure that my button can do the same thing. So I want to make sure that the button, if you do hit this sign up button, that it is going to sign in with web UI. So let's just make sure that we have that just as a backup in case something doesn't work. Oh no, I forgot to pull up my email because it's actually going to build in. Okay, so as you can see, Amplify Days Photos wants to use awscognito.com to sign in. So let's go ahead and do that. And okay, so now I'm going to show you guys how easy it is to just sign in. So this is my sign in screen, right? But what I need to actually do is sign up because I don't have a user account. So I'm just going to say username is Kilo, and I think I have an email at kiloloco@me.com, and then I also want my password to be super hard to figure out, so I'm going to put in password all lowercase. So now it actually is going to be sending me an email. Let's just hope that comes in a
No one spam personal email, please. Thank you.
Yeah. Okay, it came in, and we can add that in. 346, and before I have that, I'm just going to clear the logs so we can see it. Confirm account. Bam, it closes. Sign in succeeded. So now, as you can see, bam, we get sign in succeeded. So as you can see, I set up an entire auth flow, and that was really quick, and I was just copying and pasting docs, right? So what we also need to do is we also need to make sure that we're able to send like the user's identity ID over to the main part of the app so that we can sign each of our photos with it, right? So let's go ahead and add in a closure right here that will allow us to pass our identity ID. So did sign in, and we're going to be receiving a string, and we're going to pass it into a closure like that. So did sign in. So whenever we do sign in, what we're actually going to do is I'm going to call fetch current auth session again, because this session will now say it is signed in, and I'll actually be able to get the identity ID. So what we're going to do is I'm going to actually say as AWS auth, let me see. I think I need the plugins for this part. AWS auth session, Cognito session. There we go.
Casting the result.
Yes, and that will actually make it so that if it is not this type, then it will actually fail, which means that we need to change this to default. And we won't print out an error because it won't always have an error. So now what we do is we have this session. So session dot get identity ID, and I think this one, okay, dot get. Okay, so now what I'm doing is I'm actually getting the identity ID of the user that signed in so that we're able to pass it. So let's ID is equal to that, and we need to throw it, and we need to wrap it in a do catch block as well. So we'll just print out an error if for whatever reason it doesn't work, right? So now we got the ID, and now what we want to do is we want to pass it to the did sign in. And we also want to make sure that when we did successfully sign in with the sign in with web UI, that we are calling the fetch current auth session again. So let's go ahead and do that one more time. And as you can see, we also have an error right here because reasons of Swift UI. And let's just go ahead and pass this in.
Love that.
All right.
It's always a good reason. All right.
Oh,
So
this will also fail. So the reason why it's going to fail is because we have this auth, let's see, well, two reasons, right? One right here, but also back over in our app, what we have is this right here. So this is where we're actually calling it. And what we now have is this closure. So now we got this user ID, right? And we actually need to do something with that user ID. So let's go ahead and make sure that we hold on to that user ID. And I hope I'm not going too fast. I know it's really fast, everybody, but I'm trying to go as fast as I can in order to beat the clock, to show you something cool. And this is the only way to do it.
I mean, since it's delayed, it doesn't look that fast.
Oh, okay.
For me,
All right, so
I
now
think
what we're gonna
it's
do,
possible to get something up and running with Amplify though.
yeah, so we already finished the auth flow. Now I'm just trying to get into the session flow, right? So as long as we have the user ID, what I wanna do is I wanna be able to open up a new view. So let's go ahead and create a new view for us, a Swift UI view. And this one I'll go ahead and call a gallery view. And when I open up my gallery view, I want to make sure that I pass in my user ID, right?
Mm-hmm.
And just so that we can see something happen, let's go ahead and show the user's ID when we sign in. So now I have my gallery view, user ID, and this closure, or this is unwrapping the user ID, so I can pass it in. So now we should be able to see that we're actually going to be automatically logging in with, one second, we should be automatically logging in since we already signed in to a session with Amplify. Okay, here we go. So we open it and we should see the user ID. So we're no longer seeing the auth screen because we already signed in, which is really cool. So now we need to add some stuff to the gallery view. Now, what I want to do is I want to cheat a little bit. I do want to cheat a little bit. And what I'm going to do is I'm going to grab our navigation view.
Okay.
Right. And inside of this, we can also use text just so that we have something right now. And what we want to do is we want to present some stuff on it. So I have some previously written code that's going to get us moving a little bit quicker. And all this is going to do is simply wrap it in a navigation view just so that we can see that it shows photos at the top and it looks a little bit cleaner, right? So a little bit nicer. And we also have this log out button that's not currently tied to anything. So let's go ahead and add the ability to log out, Amplify like this. And once again, heading back over to the docs, let's see, sign in. I want to say that's the one. And
Oh, dual view, by the way, of like Xcode and the simulator.
oh yeah, I like it. I can't, oh, sign out right there. It has a whole entire tab dedicated to it. So sign out. And we'll just go ahead and use this one. And let's go ahead and create a new function called log out. Throw that in there, and I believe everything should work. And what we'll do is we'll call log out. Now, in order for this to actually work as expected, what I want to do, like, it will work when I relaunch right now because I'll be logged out. But what I wanted it to do is actually go back to the sign in screen. So that means that we actually have to have another closure in here that's going to say like did sign out. There we go. And what we'll do is when we sign out successfully, we'll just call did sign out like this. And we can also add did sign out like this right there. And what we'll do is over back in our app object will now have a closure just like this one that will allow us to set self.user ID to nil, right?
Yep.
Let's see. an argument. Oh, because I accidentally made it a string. So this is actually empty. So let's go ahead and try that one more time. And while that's building, let's go ahead and keep going because I want to try to get some of the cooler stuff in here. So what we want to do is, oh, there we go. We'll go ahead and sign out. Now we can sign up. We can sign in. And
So
I
now
think my
storage, right?
I think my username was Kilo and my very hard password is password. And we're back in. Okay, so let's go ahead and add in some views so that we can actually get to the storage part. So now what we need to do is we need to be able to, you know, display the image picker, and then we also want to be able to send up photos.
Get rid of your title and your logout button.
Oh, yep, I did that. Got me. You caught me slipping.
So now here's where you want to add the actual gallery.
Yes. So once again, grabbing some cheater code, and this is going to allow us to grid view. Let me see. What was it called? Oh, photos grid. And we don't have photos in here, and we don't need this at the moment. But let's see. This is not implemented yet, and is uploading has not been implemented yet. Okay, so let's run this again just to show you what I have. So all I'm going to be doing is I'm going to be displaying photos. So it's going to be in a grid. So I have this photos grid right here. And then I also have this new button right here. So whenever I tap on this button, I want to be able to actually display, I want to be able to display the photos picker. So let's go ahead and add that now. So once again, cheating a little bit, but I want to get through this as fast as possible.
Can't call it cheating because, I mean.
Well, I wrote it, so.
You wrote it.
But, here we go. Bar is uploading is equal to false. So now we could pass in is uploading like that. And then we also want to do show should show photos picker. And that's going to be a Boolean. All right, so now we have those in there, and all I want to do is I want to make sure that I pull up a sheet that, oops. Okay, let's just, let me see, one sec. Cheating again, because this is not the Amplify part. This is the Swift UI struggle part right now.
That's
so
fair.
We have our photo picker, and we are getting this right now because we don't have an upload function, but should show photos picker did provide image, so like this. All right, so as you can see, we have the is uploading, so we're going to check if it's uploading or not, and then we also have this should show photos picker tab. Oh, I did it backwards, silly me. Now, what we want to do is when this thing provides an image, we want to actually upload it, right? So now what we need to do is we need to do the upload part, which we can grab from
Amplify.
the doc. All right, so now we can do, I think it was a image of UI image like this. So we'll be passing in an image, and then what we need to do is we need to go to the docs, we'll grab storage, and we'll do upload. So now we have upload data.
and you've already provisioned the bucket and done all the CLI commands appropriate to actually take advantage of this in code.
Absolutely. So yeah, so we already did like all the CLI work so that we can skip over that part. All we want to do is we just want to create a new key. So let key is equal to a UUID and UUID string like this. So now we could pass in a key and we'll make sure that we want to append this and say .jpeg, right? And we're going to be getting a image data. We don't want this generic data. We want the image data. So let image data is equal to, how did I do this? I always forget how, I think
you can do image and then dot.
Oh, it's image, right? Yeah. Okay, image dot JPEG something.
JPEG representation or something. Some
Yeah.
long function that.
Well, they changed it. So now it's like a dot syntax, which is really nice.
Okay.
That's why I forget.
It used to be like with JPEG representation or something long like that.
Yeah, it was pretty nasty. So let's see. We have this, and hold on. Where is it going wrong? So we have the key. We have.
Oh, it's optional.
Oh, is it optional? That's what it is.
Data, yeah.
But it says something about consecutive.
And breakout if it's null.
And this. So this is giving me a problem. There's too many of these, apparently. And yeah, we're still hitting.
Could you do multiple trailing closures, and could you just put the end bracket or the end of the parentheses at image data and do, could you do that now since you're in the new Xcode?
You could, yeah. But right now this is just the code that was copied so far. So let's make sure that this is able to run, and I want to see if I can actually get the image picker. So it looks like it was able to run, so that's good. We're able to call upload, so that's good. Let's see if we could get the photo picker to show. And it's not showing quite yet. We have the photo picker right here. When we tap the button, we are not doing anything. So that's the problem right there. So show photo picker. Let's run that. So now what we have is this upload function tied to it, right? So as long as we're past a UI image, we're going to compress it just so that it's smaller so we can send it up. We're going to create a key. We're gonna say this is what we want the key to be in S3. We're going to send the data to S3. We have this progress listener, and then there will eventually be a result whether it was saved or not. So let's go ahead and add that in. So these two actually break. I don't know why. It's a weird Xcode thing, so I'm not going to choose either one of these. So let's go ahead and add in a leaf.
Is that a bug in the Xcode beta?
Oh, okay. So it completed. Yeah. Xcode beta bugs for the win, but not really. So what actually happened was it got uploaded, and it might take too long to show it, but what we have right now is this image. As you can see, it says that it was uploaded completely. So now what we need to do is, now that we have the image saved to S3, and unfortunately this one isn't going to show in our Photos app, but everything after here is going to start showing. So what we're going to do is we're going to start using data store. So let's go ahead and create a new photo. How are we doing on time, Nikki?
I think we're doing good. We did get a late start, so we were supposed to start at 11:10 and we started at like 11:20.
Okay, awesome. And
running out of time. Let me double check.
Create. All right, so we're going to create a new photo, and we're going to use data store for this point. And once again, just going to pull straight from the docs right here. So we're going to save the same way that they decided to save, except what we're going to do is we're going to actually save a new photo. So let photo is equal to a new photo object that I already created for us. And what we're going to do is we're going to pass in the key, right? And then we're going to sign it with the user ID. So it's going to be associated with this user ID, right? So then what we want to do is we want to save that photo, right? And after we post the photo successfully, what we want to do is we also want to get the resulting photo. So let photo, and we'll say self dot photos. Do I not have a photos up here? We don't have a photos up here yet. So let's go ahead and add an array of photos to hang on to.
So that's how you're going to display it.
And we need to make sure that this is tied to our photos grid.
All right, so
Like
we are cool to go a little over if everybody is willing to allow us to go a little over and continue live coding.
If you want to see us keep going, then make sure you say so, because we're we're a little bit slower than anticipated, but I think it's still pretty cool to keep
We
going.
have some other cool stuff coming that hasn't been shown yet too. So let us know if you want to keep going. Okay, everybody's saying keep going, keep going,
Awesome.
keep going, keep going.
Okay, so all right.
Amplify is not available for Objective-C. It was written entirely in Swift, since that is the direction moving forward for mobile applications from Apple. You could probably write your own Objective-C headers to import the Swift, but we wrote the whole thing in Swift, and we're going to do everything in Swift moving forward at AWS.
Yes. Okay, so as you can see, there is something showing right here, and the reason it's not showing is because I missed a step, and the part that I missed was the image loader. So I have this image loader class which is tied to the view that actually presents the downloaded image, and the way that we're going to actually add in the image loader is we're going to be using data store. So I need to make sure that I add in or not data store, storage, I'm sorry. We're going to be downloading from storage or S3, and we're going to be getting that data that way. So let's go ahead and add that in right now. And let's go ahead and we'll once again jump back to the docs because they're so beautifully written. We'll go down to download, and we want to get it by key. So right here. So if I just go ahead and paste that in there, and we don't want to use my key, we want to use the image key that's being passed in, image key. And let's see, we may have a similar problem as before. No, I think this looks pretty good to me. If we successfully do this, then what we want to do is we want to create an image. So we'll create an image from the data. So UI image, and we'll do that from data, like so. And I think this is optional, or it's optional. So let's go ahead and unwrap it. All right, so now we have our image, and what we want to do is we want to make sure that we just send it to a cache before we try to use it again. So we'll do image cache, and this is something that I implemented myself, but all the code will be accessible to you, so you can see how I did it. You can do it a more optimized way. That's absolutely fine. But all we're going to do is let me see, add image for. And we have the image key, like so. So now we have that, and then all we need to do is we just want to make sure that we return it back. Huh. Is my screen still showing?
Yeah. Why?
Okay, because something weird just happened on my computer, and I'm not sure what it was, but I can keep going.
I still see it. Does everybody else still see it?
Okay,
You're
so
attaching to the main queue to update the UI, right?
correct. So I have this image, and I'm sending it to image, which is up here. So let's go ahead and see if this works. Because syntax highlighting just died on me and I don't really know if it's working or not.
Xcode beta, this is why I have not upgraded yet.
Okay, so it would probably be showing right now, but since I haven't implemented a get photos thing, it's not showing. So let's go ahead and add another image just so that we can see that it's going to be uploading, and then we should get it back. And as you can see, bam, it's right there, it's showing. So super awesome. All right, let's keep going. I want to celebrate these small victories, but we don't got the time for that. Okay, so let's just go ahead and throw in, we're back over here on the gallery view, and I want to get the photos, right? And once again,
Why do you want, wait,
are
you're
amazing.
already displaying the photos, so what is this one for?
So the reason why we're displaying the photos is, let's see, where is it? Oh, the reason why it's displaying the photos right now is simply because I'm appending it to the array that's supposed to be displaying it, but we don't actually have a place that we're getting the photos. So that's the problem. So once again, docs are really good. And we're gonna run a query. This is what we want right here. So we're gonna run a query. And now, instead of post, we wanna do photo. We get the photos back, right? This is an array of photos. And we'll just say self.photos is equal to photos. All right, now what we want to do is we want to make sure that we're calling this whenever our view appears. So on appear.
Got it.
Okay, come on. Okay, so now we want to get photos. That is no. Okay.
Fun code completion problems you're having.
Yes.
Yes, I don't upgrade.
Okay, so get photos should be called whenever this gallery view appears, and now we're getting, oh, I guess, oh, you know what it is I actually didn't clean out my database, so you get to see my dirty database, but they are coming in, and it's all showing right here, which is really cool. Let's see, just so that I can
For the record, you now built this app in like 30 minutes, like a working app with auth and storage and displaying the photos beautifully.
Yes. So there's a lot going on, a lot of cool stuff. I think I'm going to try to skip a couple more things that I wanted to do, and I want to jump into the cool part because we're already running over. And what I want to do is I want to jump over to the cool part that me and Nikki have been working really hard to get working, which was using Lambda, and we actually did it in Swift. So there's this other area up here called featured photos, and what you'll actually see is any photos that have a waterfall in it. Now, it may have dirty data in there, to be honest. I obviously forgot to clear out some of the data, but what's happening in the background is the Lambda is actually observing anytime a DynamoDB event or anytime a new photo is added to our DynamoDB database. And what's happening is we're using the Lambda to use recognition on the photo. So if it has a waterfall, which is why we have so many waterfall pictures, if it has a waterfall on it, we're going to consider it to be featured. You know, we just wanted to show something like kind of cool of what we could possibly do.
Lambda.
So let's go ahead and get our featured photos. And oh, so we did everything up to this point with data store, but I also wanted to show you that we can do everything with API as well. So like if you didn't want to use data store and you wanted to use GraphQL API or anything like that, you could also do that. And let's go ahead and grab the docs for that. I use this one, API GraphQL, getting started.
We are going to show the Lambda code at some point.
Yes, we will show the Lambda. Oh, I can show it right now. Should I do it? There may not be a quick way to show this in the docs. Let me see, fetch data. Okay, here we go. List to-dos. Okay, so this is essentially what we want, but we want photos, right? So let's go ahead and grab that, and we'll just throw this in. This is doing it with a predicate. We don't need all of that necessarily. I suppose we could do it with photos, but we'll just filter it on our side. So what I want to do is I want to get photos, photo, and when we get an event, this is all great and all, but I think it could be slightly sexier if we just did it like this. So what we're going to do is we're going to simply say do catch, and we'll print the error. And what we'll do is we'll say let photos or featured photos equal event.get. And the reason for that is because get is unwrapping a result type, and this is also a result type. So instead of doing like two switch statements, we can just do it like this. So now we have these featured photos that we also want to
bracket
filter.
End bracket. And on line 81, you need another end.
On line 81.
Yeah, because you started a closure on 73 and then you didn't end it.
Oh, got it. Good catch. It's my partner right there. Okay, so if these photos have is featured set to true, then we're going to pass them into this right here. That's what we want. My bad. All right. So now what we need is a featured photos array. So let's go ahead and add that. We're almost there, guys. I'm sorry.
We're close.
We're so close. We are so close. Featured photos. Let's get rid of this. All right, so now we're going to pass anything that is featured into the featured photos, and we just need to make sure that we're presenting that. So we have this featured view, and all we need to do is pass in some photos, and we're going to pass in the featured photos. So now, and we also need to make sure that we're calling the get featured photos. Get featured photos. All right, so if this works, we should be able to see both the regular photos and the get featured photos. And here they are. So these are the featured photos, and only the waterfalls are going to show up. I did experience this. I think that it is a Swift UI bug. Unfortunately, I'm not really sure why it's happening, but I do know that the data has been downloaded. So it's not an Amplify thing. I think it is a beta thing, to be honest, with Swift UI. I am on beta, but if we just go ahead and like delay this, like async after, and then deadline is going to be like, we're going to delay it by like a second, right? Then I believe that all this starts to work, which it's a sucky workaround right now, but beta technology, what can you do? So
Lambda.
What's that?
Let's show the Swift Lambda code. So like what's actually happening to actually trigger those photos to be featured.
Yes, absolutely. Okay, and as you can see, all of the stuff is loaded too. So now let's go ahead and show the Lambda code. And as you can see here, we're simply setting up some environment variables. Then we're also using like the different services that we're going to be interacting with, right? S3 to check the image, recognition to identify the image and check what like tags or labels are associated with that image, and then our DynamoDB database. And as you can see, it's like all Swift code. Some of it may not seem so Swifty. I know that me and Nikki definitely didn't feel like it was too Swifty because we were dealing with event loop futures, which neither of us are experts at, but it was definitely an interesting learning experience for sure.
So we're using the community SDK. There's a community SDK in Swift, so we're taking advantage of that. But also the Swift Lambda runtime comes with some built-in things. So if you go back to the Lambda, there's a package called AWS Lambda Events that the Swift Lambda runtime is giving us. And that basically helps us set up, like on line 19, we start the Lambda, and we're actually saying what we're going to receive is a Dynamo event, if you see that there. So we can receive all kinds of events in our Lambda. We can receive events from S3. We can receive events from SNS. We can receive events from a lot of different places. And instead of having to write that code ourselves, they've actually just mapped the objects to decodable objects for us, which is really nice. And you can just import the events object and use it in code.
Yeah. And that's what we're doing right here. We're going through S3, then we're checking, does it have a waterfall in it? And then if it does, then we move forward and then we say, yeah, it does have a waterfall. And over here on the DynamoDB, we're updating it to make sure that like we're flipping that switch. One thing that I did want to show the audience though is that we have these two images right here, and I wanted to upload a new image with a waterfall on it. We could do either of these. I'm going to do this one, whatever. I want to see that it shows up right here, but I also want to see that it eventually comes in here. Now, remember that it's going to take a couple of seconds for it to actually work, but also in order for me to update this featured photos right here, it's only being called right here on the on up here somewhere. Get featured right here. So what we need to do is we actually need to reload the app and see if it actually detected it as something that has a waterfall on it. Oh, there's a third one. Okay, so as you can see, it is there, but let's like also make sure that it's not just saying anything is a waterfall, right? So let's go ahead and throw in like these flowers or something like that, right? So it gets loaded right here, and we just want to make sure that no, it's not going to be counted as a waterfall. So we're going to give it a couple seconds, and then we're going to rerun it. And we would just want to make sure that that other picture is not there. So as you can see,
image inside DynamoDB streams is actually triggering the Lambda function, which double checks by recognition if there's a waterfall, and then updates that row in DynamoDB, which it flips the Boolean.
Yes. And I think I'm going to leave it right there. What do you think, Nikki? We already spent a little bit more than over.
Yeah. So just show the last slide of our PowerPoint for the GitHub repos of where all this code lives, both the Lambda and the app, and then our information.
Yes.
Yeah, that is the end. Thank you guys for staying with us, whoever stayed over, and for letting us know you wanted us to keep going.
Where's that slide?
Bingo. Oh, so you even had a QR code for everyone.
Yes, so you can just, bam, pull up your phone, and then you could get like the repo right there, and it's like so easy to see.
Lambda,
yeah,
it's my account. It's pinned though.
Yes, so if you go to this repo, just to say real quick, if you go to this repo, whether through the QR code or through the link directly, why did it do that? Okay, I'll make sure that this link works. I'm pretty sure that it does. There shouldn't be a problem there. But if you go to this repo, what you'll actually see is like there's 3 different branches. I'm going to upload to Amplify Days. This is where everything that I covered in this talk is at. This is the starter branch of where I started from, and then the main branch is like the one that has everything in it. So if you want to take a look at all that, and then the code that we worked on with Lambda is right here at the bottom. So make sure you check that out. It's really, really cool. It allows you to get Swift up and running on Lambda, and you know, Nikki even like made it super easy on which commands that you need to do in order to build and like upload it as a zip. So I think that's pretty much it that I have to say. But like going back to our information on where you can find us at, our GitHubs are right here, and our Twitter handles are right here.
Oh, they said the QR code worked.
Awesome.
Awesome. Well, it's been a total pleasure building this with you, Kyle. It was so fun. And awesome job live coding. That was incredible.
Same here. It was super. I learned so much, especially around Lambda with this. But yeah, thank you all for like sticking around so much longer than what was anticipated.
Awesome live coding. That was great. I think that you all kind of built what sometimes takes people days or even weeks to build in like less than an hour. So that's pretty cool. So congrats on that. So yeah, thank you for the presentation. I think we're wrapping up Amplify Days as far as the talks are concerned, but hang around because we're actually going to now talk about the workshop that we're about to do. And if you'd like to follow along, we're actually going to have our Discord server set up with a special channel for anyone participating in the workshop for the next few hours to get hands-on help with this workshop. So I'm going to be in there. A bunch of people from our team are going to be in there answering questions and stuff. So I'll go ahead and try to share my screen actually. And I'm going to kind of walk through what this workshop is going to look like. It's just 1 second for me to get this. All right, so basically we're going to be going to this Discord channel that's located at discord.gg/amplify. It's the official AWS Amplify Discord. And you can go there and you will be able to join the server to kind of talk about the workshop. And there is an events section that you can join. And then in there, we have the Amplify workshop stuff going on. And then the workshop itself is going to be this Amplify photo sharing workshop. And it's going to be linked in Discord for you to kind of be able to go to. But it's at my GitHub. So if you go to github.com/dabbit3, you'll see that the first thing under my main repos is this Amplify photo sharing workshop. And essentially what we're building is kind of like a very basic version of something like Instagram or really any posting application that you could think of. So a lot of apps have really the same functionality. If you really think about some of the base functionality for a lot of the popular apps, Facebook, Twitter, Instagram, even blogs, they have this idea of posting and adding content and authorization management. So you have the ability to post, you have the ability to update your own posts, and you have the ability to read other people's posts. And along with that, you kind of modify things to add additional functionality. So for Instagram, you have the ability to add a single image. With Twitter, you have the ability to add text and images, so on and so forth. So we're basically going to be building the entire infrastructure behind this application and the front end, and we're walking through it in steps. So we start off really basic by adding authentication. We then add an API. We test it all out. We then add storage so you can upload images. Then we test that out, and then we end up building the entire app from scratch. After we test that, we add hosting so we can then deploy it to a live domain using GitHub and an Amplify console. And then the last step is we update the existing application to add more advanced features around authorization and being able to kind of specify and determine who has permissions to do what. So that way you're able to kind of only allow the people that created their own posts to update or delete. And then you have different views. So you'll have like a view to view all the posts and then a view to view only your own posts. So that's kind of what we're going to be walking through. And everything is going to be laid out in this workshop README. So you kind of will walk through these steps and you kind of go from getting started into each step. And everything should be really, really straightforward as far as copying and pasting. Everything should just work. All this code has been tested out quite a few times. I made some updates today to make this even easier. And then in the Postogram folder is actually the entire kind of reference architecture for this application that's built out. So if you run into any issues, you can actually just drill down into this folder and you'll be able to see in this source directory, we have all the components on the front end. And in the Amplify director, we have everything on the back end, including, for instance, you can go into the API and you can see the schema that we're going to be kind of working with. So everything is here. You should be able to kind of get through it, but you will inevitably probably run into some issues. And when you do, jump into Discord and have those conversations, and we'll be there to help you out. And yeah, I think that's about it. So I'm going to go ahead and say that. Let's see if I can stop sharing my screen. Okay, there we go. So now we're back. You know, we have me, Kyle, and Nikki. So that wraps up Amplify Days. So again, Nikki, thank you so much for your help as far as being one of the hosts for the event. I think you might be on mute. I'm sorry.
Ed, my pleasure. Thank you for having me. This was an amazing conference, and I'm really happy to be a part of it. And thanks to Kyle for that awesome work of our app.
Yes, that was some hardcore live coding. I mean, I haven't seen that hardcore live coding in a while, and you all pulled it off. So props for that. Don't forget to follow Kyle and Nikki on Twitter, and also everyone else that you've seen in this event if you're interested in hearing more from us. And with that, we'll go ahead and call it a wrap. So we'll see you on Discord, and everyone have a great week.